Jurassic Park.
They moved into a green tunnel of overarching palms leading toward the main visitor building. Everywhere, extensive and elaborate planting emphasized the feeling that they were entering a new world, a prehistoric tropical world, and leaving the normal world behind. Ellie said to Grant, "They look pretty good." "Yes," Grant said. "I want to see them up close. I want to lift up their toe pads, inspect their claws, feel their skin, open their jaws, and have a look at their teeth. Till then, I can't know for sure, but yes, they look good." I suppose it changes your field a bit," Malcolm said. Grant shook his head. "It changes everything," he said. For 150 years, ever since the discovery of gigantic animal bones in Europe, the study of dinosaurs had been an exercise in scientific deduction. Paleontology was essentially detective work, searching for clues in the fossil bones and the trackways to the long-vanished giants. The best paleontologists were the ones who could make the most clever deductions. And all the great disputes of paleontology were carried out in this fashion, including the bitter debate, in which Grant was a key figure, about whether dinosaurs were warm-blooded. Scientists had always classified dinosaurs as reptiles, cold-blooded creatures drawing the heat they needed for life from the environment. A mammal could metabolize food to produce bodily warmth, but a reptile could not. Eventually, a handful of researchers, led chiefly by John Ostrom and Robert Bakker at Yale, began to suspect that the concept of sluggish, cold-blooded dinosaurs was inadequate to explain the fossil record. In classic deductive fashion, they drew conclusions from several lines of evidence. First was posture. Lizards and reptiles were bent-legged sprawlers, hugging the ground for warmth. Lizards didn't have the energy to stand on their hind legs for more than a few seconds, but the dinosaurs stood on straight legs, and many walked erect on their hind legs. Among living animals, erect posture occurred only in warm-blooded mammals and birds. Thus, dinosaur posture suggested warm-bloodedness. Next, they studied metabolism, calculating the pressure necessary to push blood up the 18-foot-long neck of a brachiosaurus, and concluding that it could only be accomplished by a four-chambered, hot-blooded heart. They studied trackways, fossil imprints left in mud, and concluded that dinosaurs ran as fast as a man. Such activity implied warm blood. They found dinosaur remains above the Arctic Circle, in the frigid environment unimaginable for a reptile. And the new studies of group behavior, based largely on Grant's own work, suggested that dinosaurs had a complex social life and reared their young, as reptiles did not. Crocodiles and turtles abandoned their eggs, but dinosaurs probably did not. The warm-blooded controversy had raged for 15 years before a new perception of dinosaurs as quick-moving, active animals was accepted, but not without lasting animosities. At conventions, there were still colleagues who did not speak to one another. But now, if dinosaurs could be cloned, why, Grant's field of study was going to change instantly. The paleontological study of dinosaurs was finished. The whole enterprise, the museum halls with their giant skeletons and flocks of echoing schoolchildren, the university laboratories with their bone trays, the research papers, the journals, all of it was going to end. You don't seem upset?" Malcolm said. Grant shook his head. "It's been discussed in the field. Many people imagined it was coming, but not so soon." "Story of our species," Malcolm said, laughing. "Everybody knows it's coming, but not so soon." As they walked down the path, they could no longer see the dinosaurs, but they could hear them trumpeting softly into the distance. Grant said, "My only question is where they get the DNA." Grant was aware of serious speculation in laboratories in Berkeley, Tokyo, and London that it might eventually be possible to clone an extinct animal such as a dinosaur, if you could get some dinosaur DNA to work with. The problem was that all known dinosaurs were fossils, and the fossilization destroyed most DNA, replacing it with inorganic material. Of course, if a dinosaur was frozen or preserved in a peat bog or mummified in a desert environment, then its DNA might be recoverable. But nobody had ever found a frozen or mummified dinosaur, so cloning was therefore impossible. There was nothing to clone from. All the modern genetic technology was useless. It was like having a Xerox copier with nothing to copy with it. Ellie said, "You can't produce a real dinosaur because you can't get real dinosaur DNA. Unless there's a way we haven't thought of," Grant said. "Like what?" she said. "I don't know," Grant said. Beyond a fence, they came to a swimming pool which spilled over into a series of waterfalls and smaller rocky pools. The area was planted with huge ferns. "Isn't this extraordinary?" Ed Regis said. Especially on a misty day, these plants really contribute to the prehistoric atmosphere. These are authentic Jurassic ferns, of course. Ellie paused to look more closely at the ferns. Yes, it was just as he said. Serena viniformans, a plant found abundantly in fossils more than 200 million years old, now commonly only in the wetlands of Brazil and Colombia. But whoever had decided to place this particular fern at poolside obviously didn't know that the spores of viniformans contain a deadly beta-carotene alkaloid. Even touching the attractive green fronds would make you sick, and if a child were to take a mouthful, he would almost certainly die. The toxin was 50 times more poisonous than oleander. People were so naive about plants, Ellie thought. They just chose plants for appearance, as they would choose a picture for the wall. It never occurred to them that plants were actually living things, busily performing all the living functions of respiration, ingestion, excretion, reproduction, and defense. But Ellie knew that in the Earth's history, plants had evolved as competitively as animals, and in some ways more fiercely. The poison in Serena viniformans was a minor example of the elaborate chemical arsenal of weapons that plants had evolved. There were terpenes, which plants spread to poison the soil around them and inhibit competitors, alkaloids, which made them unpalatable to insects and predators, and children, and pheromones used for communication. When a Douglas fir tree was attacked by beetles, it produced an anti-fedin chemical, and so did other Douglas firs in distant parts of the forest. It happened in response to a warning alleochemical secreted by the trees that were under attack. People who imagined that life on Earth consisted of animals moving against a green background seriously misunderstood what they were seeing. That green background was busily alive. Plants grew, moved, twisted, and turned, fighting for the sun, and they interacted continuously with animals, discouraging some with bark and thorns, poisoning others, and feeding still others to advance their own reproduction, to spread their pollen and seeds. It was a complex, dynamic process which she never ceased to find fascinating, which she knew most people simply didn't understand. But if planting deadly ferns at poolside was any indication, then it was clear that the designers of Jurassic Park had not been as careful as they should have been. "Isn't it just wonderful?" Ed Regis was saying. "If you look up ahead, you'll see our safari lodge." Ellie saw a dramatic low building with a series of glass pyramids on the roof. "That is where you'll all be staying here in Jurassic Park." Grant's suite was done in beige tones. The rattan furniture and green jungle print motifs. The room wasn't quite finished. There were stacks of lumber in the closet and pieces of electrical conduit on the floor. There was a television set in the corner with a card on top. Channel 2, Hypsilophodon Highlands. Channel 3, Triceratops Territory. Channel 4, Sauropod Swamp. Channel 5, Carnivore Country. Channel 6, Stegosaur South. Channel 7, Velociraptor Valley. Channel 8, Pterosaur Peak. He found the names irritatingly cute. Grant turned on the television but got only static. He shut it off and went into his bedroom and tossed his suitcase onto the bed. Directly over the bed was a large pyramidal skylight. It created a tinted feeling like sleeping under the stars. Unfortunately, the glass had to be protected by heavy bars so that striped shadows fell across the bed. Grant paused. He had seen the plans for the lodge, and he didn't remember bars on the skylight. In fact, these bars appeared to be a rather crude addition. The black steel frame had been constructed outside the glass walls, and the bars welded to the frame. Puzzled, Grant moved from the bedroom to the living room. His windows looked out to the swimming pool. "By the way, those ferns are poison," Ellie said, walking into his room. "But did you notice anything about the rooms, Alan?" "They changed the plans." "I think so, yes." She moved around the room. "The windows are small," she said. "And the glass is tempered, set in a steel frame. The doors are steel clad. That shouldn't be necessary. And did you see the fence when we came in?" Grant nodded. The entire lodge was enclosed within a fence with bars of inch-thick steel. The fence was gracefully landscaped and painted flat black to resemble wrought iron, but no cosmetic effort could disguise the thickness of the metal or its 12-foot height. "I don't think the fence was in the plans either," Ellie said. "It looks to me they turned this place into a fortress." Grant looked at his watch. "Well, be sure to ask why," he said. "The tour starts in 20 minutes. When dinosaurs ruled the earth. They met in the visitor building, 2 stories high, and all glass with exposed black anodized girders and supports. Grant found it determinedly high-tech. There was a small auditorium dominated by a robot Tyrannosaurus Rex, poised menacingly by the entrance to an exhibit area labeled When Dinosaurs Rule the Earth. Farther on were other displays, What is a Dinosaur, and the Mesozoic World, but the exhibits weren't completed. There were wires and cables all over the floor. Gennaro climbed up on the stage and talked to Grant, Ellie, and Malcolm, his voice echoing slightly in the room. Hammond sat in the back, his hands folded across his chest.
We're about to tour the facilities, Gennaro said. I'm sure Mr. Hammond wanted to review why we are here and what I need to describe before we leave. Basically, as you all realize by now, this is an island in which genetically engineered dinosaurs have been allowed to move in a natural park-like setting, forming a tourist attraction. The attraction isn't open to tourists yet, but it will be in a year. Now, my answer for you is a simple one. Is this island safe? Is it safe for visitors? And is it safely containing the dinosaurs?
Gennaro turned down the room lights.
There are two pieces of evidence which we have to deal with. First of all, there is Dr. Grant's identification of a previously unknown dinosaur on the Costa Rican mainland. This dinosaur is known only from a partial fragment. It was found in July of this year and after it supposedly bit an American girl on the beach. Dr. Grant can tell you more later. I've asked for the original fragment, which is in a lab in New York, to be flown here so we can inspect it directly. Meanwhile, there's a second piece of evidence. Costa Rica has an excellent medical service and it tracks all kinds of data. Beginning in March, there were reports of lizards biting infants in their cribs, and also, I might add, biting old people who are sleeping soundly. These lizard bites were sporadically reported in coastal villages from Ismailoya to Butaneras. After March, lizard bites were no longer reported. However, I have this graph from the Public Health Service in San Jose of infant mortality in the towns of the West Coast earlier this year. I direct your attention to two features of this graph,
Gennaro said.
First, infant mortality is low in the months of January and February, then spikes in March, then it's low again in April. But from May onward, it is high right through July, the month the American girl was bitten. The Public Health Service feels that something is now affecting infant mortality and it is not being reported by the workers in the coastal villages. The second feature is this puzzling bi-weekly spiking, which seems to suggest some kind of alternating phenomenon at work.
The lights came back on.
Alright,
Gennaro said.
That's the evidence I want to explain. Now, are there any?
We can save ourselves a great deal of trouble, Malcolm said. I'll explain it for you now.
You will?
Gennaro said. Yes, Malcolm said. First of all, animals have very likely gotten off of the island. Oh, balls, Hammond growled from the back. And second, the graph from the Public Health Service is almost certainly unrelated to any animals that have escaped. Grant said, and you know that. You'll notice that the graph alternates between high and low spikes, Malcolm said. That is characteristic of many complex systems. For example, water dripping from a tap. If you turn on the faucet just a little, you'll get a constant drip, drip, drip. If you open it up a little bit more, so that there's a bit of turbulence in the flow, then you'll get alternating large and small drops, drip, 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 like that. You could try it yourself. You know, turbulence produces alternation. It's a signal, and you will get an alternating graph like this for the spread of any new illness in a community. Why do you say it isn't caused by any escaped dinosaurs? Grant said. Because it is a non-linear signature, Malcolm said. You need hundreds of escaped dinosaurs to cause it, and I don't think hundreds of dinosaurs have escaped, so I conclude that some other phenomenon, such as a new variety of flu, is causing the fluctuations you see in the graph, Gennaro said.
But you think the dinosaurs have escaped?
Probably, yes.
Why?
Because of what you are attempting here. Look, this island is an attempt to recreate a natural environment from the past to make a isolated world where extinct animals roam freely, correct?
Yes.
But from my point of view, such an undertaking is impossible. The mathematics are so self-evident that they don't need to be calculated. It's rather like my asking you whether on $1 billion in income you had to pay tax. You wouldn't need to pull out your calculator to check. You'd know tax was owed. And similarly, I know overwhelmingly that one cannot successfully duplicate nature in this way or help to isolate it.
Why not? After all, there are zoos.
Zoos don't recreate nature, Malcolm said. Let's be clear. Zoos take the nature that already exists and modify it very slightly to create holding pens for animals. Even those minimal modifications often fail. The animals escape with regularity, but a zoo is not the model for this park. This park is attempting something far more ambitious than that. Something much more akin to making a space station on Earth. Gennaro shook his head.
I don't understand.
Well, it's very simple. Except for the air, which flows freely, everything about this park is meant to be isolated. Nothing gets in or nothing out. The animals kept here are never meant to mix with the greater ecosystems of Earth. They're never to escape. And they never have, Hammond snorted. Such isolation is impossible, Malcolm said flatly. It simply cannot be done. It can. It's done all the time. I beg your pardon, Malcolm said, but you don't know what you're talking about. You ignorant little snot, Hammond said. He stood and walked out of the room.
Gentlemen,
Gennaro said. I'm sorry, Malcolm said, but the point remains. What we are calling nature is in fact a complex system of far greater subtlety than we are willing to accept. We make a simplified image of nature and then we botch it up. I'm no environmentalist, but you have to understand what you don't understand. How many times must the point be made? How many times must we see the evidence? We build the Aswan Dam and claim it to revitalize the country. Instead, it destroys the fertile Nile Delta, produces parasitic infestation, and wrecks the Egyptian economy. We build the...
Excuse me,
Gennaro said.
But I think I hear the helicopter. That's probably the sample for Dr. Grant to look at.
He started out of the room. They all followed. At the foot of the mountain, Gennaro was screaming over the sound of the helicopter. The veins of his neck stood out. You did what? You invited who? Take it easy, Hammond said. Gennaro screamed, Are you out of your goddamn mind? Now look here, Hammond said, drawing himself up. I think we have to get something clear. No, Gennaro said. No, you get something clear. This is not a social outing. This is not a weekend excursion. This is my island, Hammond said, and I can invite whomever I want. This is a serious investigation of your island. Because the investors are concerned that it's out of control, we think this is a very dangerous place and you are not going to shut me down, Donald. I will if I have to. This is a safe place, Hammond said, no matter what that damn mathematician is saying. It's not, and I'll demonstrate its safety. And I want you to put them right back on that helicopter, Gennaro said. Can't, Hammond said, pointing towards the clouds. It's already leaving. And indeed, the sound of the rotors was fading. God damn it, Gennaro said. Don't you see we're needlessly risking... Hammond said. Let's continue this later. I don't want to upset the children. Grant turned and saw two children running down the hillside led by Ed Regis. There was a bespectacled boy of about 11 and a girl a few years younger, perhaps 7 or 8, her blonde hair pushed up under a Mets baseball cap and a baseball glove slung over her shoulder. The two kids made their way nimbly down the path from the helipad and stopped some distance from Gennaro and Hammond. Low under his breath, Gennaro said, Christ. Now take it easy, Hammond said. Their parents are getting a divorce, and I want them to have a fun weekend here. The girl waved tentatively. Hey, Grandpa, she said. We're here. The tour. Tim Murphy could see at once that something was wrong. His grandfather was in the middle of an argument with a younger red-faced man opposite him, and the other adult standing behind looking embarrassed and uncomfortable. Alexis felt the tension too, because she hung back, tossing her baseball in the air. He had to push her. Go on, Lex. Go on yourself, Timmy. Don't be a worm, he said. Lex glared at him, but Ed Regis said cheerfully, I'll introduce you to everybody, then we can take the tour. I have to go, Lex said. I'll just introduce you first, Ed Regis said. No, I have to go. But Ed Regis was already making introductions. First to Grandpa, who kissed them both, and then to the man he was arguing with. This man was muscular, and his name was Gennaro. The rest of the introductions were a blur to Tim. There was a blonde woman wearing shorts, and a man with a beard who wore jeans and a Hawaiian shirt. He looked like the outdoors type. Then a fat college kid who had something to do with computers, and finally a thin man in black who didn't shake hands but just nodded his head. Tim was trying to organize his impressions and was looking at the blonde woman's legs when he suddenly realized that he knew who the bearded man was. "Your mouth is open," Lex said. Tim said, "I know him." "Oh sure, you just met him." "No," Tim said, "I have his book." The bearded man said, "Hey, what book is that, Tim?" "Lost World of the Dinosaurs," Tim said. Alexis snickered. "Daddy says Tim has dinosaurs on the brain," she said. Tim hardly heard her. He was thinking of what he knew about Alan Grant. Alan Grant was one of the principal advocates of the theory that dinosaurs were warm-blooded. He had done lots of digging at the place called Egg Hill in Montana, which was famous because so many dinosaur eggs had been found there. Professor Grant had found most of the dinosaur eggs that have ever been discovered. He was also a good illustrator, and he drew the pictures for his own books. "Dinosaurs on the brain," bearded man said. "Well, as a matter of fact, I have that same problem." "Dad says dinosaurs are really stupid," Lex said. "He says Tim should get out in the air and play more sports." Tim felt embarrassed. "I thought you had to go," he said. "In a minute," Lex said. "I thought you were in such a rush." "I'm the one who should know, don't you think, Timothy?" she said, putting her hands on her hips, copying her mother's most irritating stance. "Tell you what," Ed Regis said. "Why don't we all head on to the visitor center and we can begin our tour?" Everybody started walking. Tim heard Gennaro whisper to his grandfather, "I could kill you for this." And then Tim looked up and saw that Dr. Grant had fallen into step behind him. How old are you, Tim?" 11. "And how long have you been interested in dinosaurs?" Grant asked. Tim swallowed. "A while now," he said. He felt nervous to be talking to Dr. Grant. We go to museums sometimes, when I can talk my family into it. My father's not especially interested." Tim nodded and told Grant about his family's last trip to the Museum of Natural History. His father had looked at a skeleton and said, "That's a big one." Tim had said, "No, Dad, that's a medium-sized one, a Camptosaurus." "Oh, I don't know, looks pretty big to me." "It's not even full-grown, Dad." The father squinted at the skeleton. "What is it, Jurassic?" "Geez, no, Cretaceous." "Cretaceous? What's the difference between Cretaceous and Jurassic?" "Only about 100 million years," Tim said. "Cretaceous is older?" "No, Dad, Jurassic is older." "Well," his father said, stepping back, "it looks pretty damn big to me." And then he turned to Tim for agreement. Tim knew he had better agree with his father, so he just muttered something. And then they went on to another exhibit. Tim stood in front of one skeleton, a Tyrannosaurus Rex, the mightiest predator the Earth had ever known for a long time. Finally, his father said, "What are you looking at?" "I'm counting the vertebrae," Tim said. "Vertebrae? In the backbone." "I know what vertebrae are," his father said, annoyed. He stood there a while longer, then he said, "Why are you counting them?" "I think they're wrong. Tyrannosaurs should only have 37 vertebrae in the tail. This has more." "You mean to tell me," his father said, "that the Museum of Natural History has a skeleton that's wrong? I can't believe that." "It's wrong," Tim said. His father stomped off toward a guard in the corner. "What did you do now?" his mother said to Tim. And then his father came back with a funny look on his face because of course the guard told him that the Tyrannosaurus had too many vertebrae in the tail. "How'd you know that?" his father asked. "I read it," Tim said. "That's pretty amazing, son," he said, and he put his hand on his shoulder, giving it a squeeze. "You know how many vertebrae belong in that tail? I've never seen anything like it. You really do have dinosaurs on the brain." And then his father said he wanted to catch the last half of the Mets game on TV, and Lex said she did too, so they left the museum. And Tim didn't see any other dinosaurs, which was why they had come there in the first place. But that was how things happened in his family. How things used to happen in his family, Tim corrected himself. Now that his father was getting a divorce from his mother, things could probably be different. His father had already moved out, and even though it was weird, Tim liked it. He thought his mother had a boyfriend, but he couldn't be sure, and of course he would never mention it to Lex. Lex was heartbroken to be separated from her father, and in the last few weeks, she had become so obnoxious that... "Was it 5027? Grant said. I'm sorry, Tim said.
The Tyrannosaurus at the museum, was it 5027?
Yes, Tim said. How'd you know?
Grant smiled. They've been talking about fixing it for years, but now it may never happen.
Why is that?
Because of what has taken place here, Grant said. On your grandfather's island.
Tim shook his head. He didn't understand what Grant was talking about.
My mom said it was just a resort, with swimming and tennis. Not exactly, Grant said. I'll explain as we walk along. Now I'm a damn babysitter, Ed Regis thought unhappily, tapping his foot as he waited in the visitor center. That was what the old man had told him. You watch my kids like a hawk, they're your responsibility for the weekend. Ed Regis didn't like it at all. He felt degraded. He wasn't a damn babysitter, and for that matter, he wasn't a damn tour guide, even for VIPs. He was the head of public relations for Jurassic Park, and he had much to prepare between now and the opening, a year away. Just to coordinate with PR firms in San Francisco and London, and the agencies in New York and Tokyo. It was a full-time job. Especially since the agencies couldn't yet be told what the resort's real attraction was. The firms were all designing teaser campaigns, nothing specific, and they were all unhappy. Creative people needed nurturing. They needed encouragement to do their best work. He couldn't waste his time taking scientists on tours. But that was the trouble with a career in public relations. Nobody saw you as a professional. Regis had been down here on the island off and on for the past 7 months, and they were still pushing odd jobs on him, like that episode back in January. Harding should have handled that. Harding, or Owens, the general contractor. Instead, it had fallen to Ed Regis. What did he know about taking care of some sick workman? And now he was a damn tour guide and babysitter. He turned back and counted the heads, still one short. Then in the back, he saw Dr. Sattler emerge from the bathroom. All right, folks, let's begin our tour on the second floor. Tim went with the others, following Mr. Regis up the black suspended staircase to the second floor of the building. They passed a sign that said, Closed area, authorized personnel only beyond this point. Tim felt a thrill when he saw that sign. They walked down the second floor hallway. One wall was glass, looking out onto a balcony with palm trees in the light mist. On the other wall were stenciled doors like offices. Park warden, guest services, general manager. Halfway down the corridor, they came to a glass partition marked with another sign. Biohazard, caution, biological hazard. This laboratory confirms the USG P4/EK3 genetic protocols. Underneath were more signs.
Teratogenic substances. Pregnant women avoid exposure to this area. Danger. Radioactive isotopes in use. Carcinogenic potential. Tim grew more excited all the time. Teratogenic substances? Things that made monsters. It gave him a thrill, and he was disappointed to hear Ed Regis say, Never mind the signs, they're just up for legal reasons. I can assure you, everything is perfectly safe. He led them through the door. There was a guard on the other side. Ed Regis turned to the group. You may have noticed that we have a minimum of personnel on the island. We can run this resort with a total of 20 people. Of course, we'll have more when we have guests here, but at the moment there's only 20. Here's our control room. The entire park is controlled from here. They paused before windows and peered into a darkened room that looked like a small version of Mission Control. There was a vertical glass see-through map of the park, and facing it, a bank of glowing computer consoles. Some of the screens displayed data, but most of them showed video images from around the park. There were just 2 people inside, standing and talking. The man on the left is our chief engineer, John Arnold. Regis pointed to a thin man in a button-down short-sleeved shirt and tie smoking a cigarette. And next to him, our park warden, Mr. Robert Muldoon, the famous white hunter from Nairobi. Muldoon was a burly man in khaki, sunglasses dangling from his shirt pocket. He glanced out at the group, gave a brief nod, and turned back to the computer screens. I'm sure you'll want to see this room, Ed Regis said, but first, let's see how we obtain dinosaur DNA. The sign on the door said extractions, and like all the doors in the laboratory building, it opened with a security card. Ed Regis slipped the card in the slot, the light blinked, and the door opened. Inside, Tim saw a small room bathed in green light. 4 technicians in lab coats were peering into double-barreled stereo microscopes, or looking at images on high-resolution video screens. The room was filled with yellow stones. The stones were in glass shelves and cardboard boxes and large pull-out trays. Each stone was tagged and numbered in black ink. Regis introduced Henry Wu, a slender man in his 30s. Dr. Wu is our chief geneticist. I'll let him explain what we do here. Henry Wu smiled. At least I'll try, he said. Genetics is a bit complicated, but you're probably wondering where our dinosaur DNA comes from. This crossed my mind, Grant said. As a matter of fact, Wu said, there are two possible sources. Using the Loy antibody extraction technique, we can sometimes get DNA directly from dinosaur bones. What kind of yield? Grant asked. Well, most soluble protein is leached out during fossilization, but 20% of the proteins are still recoverable by grinding up the bones and using Loy's procedure. Dr. Loy himself had used it to obtain proteins from extinct Australian marsupials, as well as blood cells from ancient human remains. His technique is so refined it can work with a mere 50 nanograms of material. That's 50 billionths of a gram. So you've adapted his technique here? Grant asked. Only as a backup, Wu said. As you can imagine, a 20% yield is insufficient for our work. We need the entire dinosaur DNA strand in order to clone, and we get it here. He held up one of the yellow stones. From amber, the fossilized resin of prehistoric tree sap. Grant looked at Ellie, then at Malcolm. That's really quite clever, Malcolm said, nodding. I still don't understand, Grant admitted. Tree sap, Wu explained, often flows over insects and traps them. The insects are then perfectly preserved within the fossil. One finds all kinds of insects in amber, including biting insects that have sucked blood from larger animals. Suck the blood, Grant repeated. His mouth fell open. You mean, suck the blood of dinosaurs? Hopefully, yes. And then the insects are preserved in amber. Grant shook his head. I'll be damned. That just might work. I assure you, it does work, Wu said. He moved to one of the microscopes where a technician positioned a piece of amber containing a fly under the microscope. On the video monitor, they watched as he inserted a long needle through the amber into the thorax of the prehistoric fly. If this insect has any foreign blood cells, we may be able to extract them and obtain paleo-DNA, the DNA of an extinct creature. We won't know for sure, of course, until we extract whatever's in there, replicate it, and test it. That is what we've been doing for 5 years now. It's been a long, slow process, but it has paid off. Actually, dinosaur DNA is somewhat easier to extract by this process than mammalian DNA. The reason is that mammalian red cells have 2 nuclei and thus no DNA in their red cells. To clone a mammal, you have to find a white cell, which is much rarer than red cells. But dinosaurs had nucleated red cells, as do modern birds. It's one of the many indications we have that dinosaurs aren't really reptiles at all. They're really big, leathery birds. Tim saw that Dr. Grant still looked skeptical, and Dennis Nedry, the messy fat man, appeared completely uninterested, as if he knew it all already. Nedry kept looking impatiently towards the next room. I see Mr. Nedry has spotted the next phase of our work, Wu said. How we identify the DNA we have extracted. For that, we use powerful computers. They went through sliding doors into a chilled room. There was a loud humming sound. 2 6-foot-tall round towers stood in the center of the room, and along the walls were rows of waist-high stainless steel boxes. This is our high-tech laundromat, Dr. Wu said. The boxes along the walls are all Hamachi Hood automated gene sequencers. They are being run at very high speed by the Cray XMP supercomputers, which are the towers in the center of the room. In essence, you are standing in the middle of an incredibly powerful genetics factory. There were several monitors, all running so fast it was hard to see what they were showing. Wu pushed a button and it showed one image. Here you see the actual structure of a small fragment of dinosaur DNA, Wu said. Notice the sequence is made up of 4 basic compounds: adenine, thymine, guanine, and cytosine. This amount of DNA probably contains instructions to make a single protein, say a hormone or an enzyme. The full DNA molecule contains 3 billions of these bases. If we looked at a screen like this a second for 8 hours a day, it'd still take more than 2 years to look at the entire DNA strand. It's that long. He pointed to the image. This is a typical example, because you see the DNA has an error. Down here in line 1201, much of the DNA we extract is fragmented or incomplete, so the first thing we have to do is repair it, or rather the computer has to. It'll cut the DNA using what we are calling restriction enzymes. The computer will select a variety of enzymes that might do the job. So here's the same section of DNA with the points of the restriction enzymes located. As you can see in line 1201, 2 enzymes will cut on either side of the damaged point. Ordinarily, we let the computers decide which to use, but we also need to know what base pairs we should insert to repair the injury. For that, we have to align various cut fragments, like so. Now we are finding a fragment of DNA that overlaps the injury area and will tell us what is missing. And you can see we can find it and go ahead and make the repair. The dark bars you see are restriction fragments, small sections of dinosaur DNA, broken by enzymes and then analyzed. The computer is now recombining them by searching for overlapping sections of code. It's a little bit like putting a puzzle together. The computer can do it very rapidly. And here is the revised DNA strand repaired by the computer. The operation you've witnessed would have taken months in a conventional lab, but we can do it in seconds.
And are you working with the entire DNA strand? Grant asked.
Oh no, Wu said, that's impossible. We've come a long way from the 60s when it took a whole laboratory 4 years to decode a screen like this. Now the computers can do it in a couple hours, but even so, the DNA molecule is too big. We look only at the sections of the strand that differ from animal to animal, or only contemporary DNA. Percent of the nucleotides differ from one species to the next. That's what we analyze, and it's still a big job. Dennis Nedry yawned. He long ago concluded that InGen must be doing something like this. A couple years earlier, when InGen had hired Nedry to design the park control systems, one of the initial design parameters called for data records with 3 times 10 to the 9th power fields. Nedry just assumed this was a mistake and had called Palo Alto to verify it, but they had told him that the spec was correct. 3 billion fields. Nedry had worked on a lot of large systems. He made a name for himself setting up worldwide telephone communications for multinational corporations. Often those systems had millions of records. He was used to that, but InGen wanted something so much larger. Puzzled, Nedry had gone to see Barney Fellows over at Symbolics near the MIT campus in Cambridge.
What kind of database has 3 billion records, Barney?
A mistake?
Barney said, laughing.
They put in an extra 0 or 2.
It's not a mistake. I checked. It's what they want.
But that's crazy.
Barney said.
It's not workable. Even if you had the fastest processors and blindingly fast algorithms, a search would take days, maybe weeks.
Yeah, Nedry said. I know. Fortunately, I'm not being asked to do algorithms. I'm just asked to preserve storage and memory for the overall system, but still, what could the database be for?
Barney frowned.
You operating under an ND?
Yes, Nedry said. Most of his jobs require non-disclosure agreements.
Can you tell me anything?
It's a bioengineering firm?
Bioengineering?
Barney said.
Well, there's the obvious.
Which is?
A DNA molecule.
Oh, come on, Nedry said. Nobody can be analyzing a DNA molecule.
He knew biologists were talking about the Human Genome Project to analyze a complete human DNA strand, but that would take 10 years of coordinated effort involving laboratories around the world. It was an enormous undertaking, as big as the Manhattan Project, which made the atomic bomb.
This is a private company, Nedry said.
With 3 billion records,
Barney said.
I don't know what else it could be. Maybe they're being optimistic designing their systems?
Very optimistic, Nedry said.
Or maybe they're just analyzing DNA fragments, but they got a RAM-intensive algorithm.
That made more sense. Certain database search techniques ate up a lot of memory.
You knew who did the algorithms?
No, Nedry said. The company is very secretive.
Well, my guess is that they're doing something with DNA.
Barney said.
What's the system?
Multi-XMP?
Multi-XMP? You mean more than one cray? Oh, wow.
Barney was frowning now, thinking that one over.
Can you tell me anything else?
Sorry, Nedry said, I can't.
And he had gone back and designed the control systems. It had taken him and his programming team more than a year, and it was especially difficult because the company wouldn't ever tell him what the subsystems were for. The instructions were simply, design a module for record keeping, or design a module for visual display. They gave him design parameters, but no details about use. He had been working in the dark, and now that the systems were up and running, he wasn't surprised to learn that there were bugs.
What do they expect? And they'd ordered him down here in a panic, all hot and bothered about his bugs. It was annoying, Nedry thought. Nedry turned back to the group as Grant asked, "And once the computers have analyzed the DNA, do you know what animal it encodes?" We have two procedures," Wu said. "The first is phylogenetic mapping. DNA evolves over time, like everything else in an organism, hands or feet or any other physical attribute. So we take an unknown piece of DNA and determine roughly by computer where it fits in the evolutionary sequence. It's time-consuming, but it can be done." "And the other way?" Wu shrugged. "Just grow it and find out what it is," he said. "That's what we usually do. I'll show you how that's accomplished." Tim felt a growing impatience as the tour continued. He liked technical things, but even so, he was losing interest. They came to the next door, which was marked fertilization. Dr. Wu unlocked the door with his security card and they went inside. Tim saw still another room with technicians working at microscopes. In the back was a section entirely lit by blue ultraviolet light. Dr. Wu explained that their DNA work required the interruption of cellular mitosis at precise instants, and therefore they kept some of the most virulent poisons in the world. Halotoxins, cosinoids, beta alkaloids, he said, pointing to a series of syringes set out under the UV light. Kill any living being in a second or two. Tim would have liked to know more about the poisons, but Dr. Wu droned on about using unfertilized crocodile ova and replacing the DNA, and then Professor Grant asked some complicated questions. To one side of the room were big tanks marked liquid nitrogen. Then there were big walk-in freezers with shelves of frozen embryos, each stored in a tiny silver foil wrapper. Lex was bored, Nedry was yawning, and even Dr. Sadler was losing interest. Tim was tired of looking at all these complicated laboratories. He wanted to see the dinosaurs. The next room was labeled hatchery. "It's a little warm and damp in here," Dr. Wu said. "We keep it at 99 degrees Fahrenheit and a relative humidity of 100%. We also run a higher O2 concentration. It's up to 33%. "Jurassic atmosphere," Grant said. "Yes, at least we presume so. If any of you feel faint, just tell me." Dr. Wu inserted his security card into the slot, and the outer door hissed open. Just a reminder, don't touch anything in this room. Some of the eggs are permeable to skin oils, and watch your heads. The sensors are always moving." He opened the inner door to the nursery, and they went inside. Tim faced a vast open room, bathed in deep infrared light. The eggs lay on long tables, their pale outlines obscured by the hissing low mist that covered the tables. The eggs were all moving gently, rocking. Reptile eggs contain large amounts of yolk but no water at all. The embryos must extract water from the surrounding environment, hence the mist. Dr. Wu explained that each table contained 150 eggs and represented a new batch of DNA extractions. The batches were identified by numbers at each table. Steg 458-2 or Trike 390/4. Waist deep in the mist, the workers in the nursery moved from one egg to the next, plunging their hands into the mist, turning the eggs every hour and checking the temperatures with thermal sensors. The room was monitored by overhead TV cameras and motion sensors. An overhead thermal sensor moved from one egg to the next, touching each with a flexible wand, beeping and then going on. In this hatchery, we have produced more than a dozen crops of extractions, giving us a total of 238 live animals. Our survival rate is somewhere around 0.4%, and we naturally want to improve that. But by computer analysis, we're working with something like 500 variables, 120 environmental, another 200 intra-egg, and the rest from genetic material itself. Our eggs are plastic, the embryos are mechanically inserted and then batched here. And how long to grow? Dinosaurs mature rapidly, attaining full size in 2 to 4 years, so we now have a number of adult specimens in the park. And, what do the numbers mean? "Oh, these codes," Wu said, "identify the various batch extractions of DNA. The first 4 letters identify the animals being grown. Over there, that trike means Triceratops, and the steg means Stegosaurus, and so on." "And this table here?" Grant said. The code said XXXX-0001-1. Beneath was scrawled, "Presumed Solur." "That's a new batch of DNA," Wu said. "We don't know exactly what will grow out the first time an extraction is done.
We don't know for sure what the animal is. You could see it's marked presumed solar, so it's likely a Coelurosaurus. Small herbivore, if I remember. It's hard for me to keep track of the names. There are something like 300 genera of dinosaurs known so far. 347, Tim said. Grant smiled and said, "Is anything hatching now?" Not at the moment. The incubation period varies with each animal, but in general it runs about 2 months. We try to stagger hatchlings to make less work for the nursery staff. You can imagine how it is when we have 150 animals born within a few days. Though, of course, most don't survive. Actually, these X's are due any day now. Any other questions? No? Alright, then we'll go to the nursery where the newborns are. It was a circular room, all white. There were some incubators of the kind used in hospital nurseries, but they were empty at the moment. Rags and toys were scattered across the floor. A young woman in a white coat was seated on the floor, her back to them. What do you got here today, Kathy?" Dr. Wu asked. "Not much," she said. "Just a baby raptor." "Let's take a look." The woman got to her feet and stepped aside. Tim heard Nedry say, "Looks like a lizard." The animal on the floor was about 1.5 feet long, the size of a small monkey. It was dark yellow with brown stripes like a tiger. It had a lizard's head and long snout. How it stood upright on strong hind legs, though, balanced by a thick, straight tail. Its smaller front legs waved in the air. It cocked its head to one side and peered at the visitors staring down at it. "Velociraptor," Alan Grant said in a low voice. "Velociraptor mongoliensis," Wu said, nodding. Predator. This one's only 6 weeks old." "I just excavated a raptor," Grant said as he bent down for a closer look. Immediately, the little lizard sprang up, leaving over Grant's head onto Tim's arms. "Hey!" "They can jump," Wu said. "The babies can jump, and so can the adults, as a matter of fact." Tim caught the velociraptor and held it to him. The little animal didn't weigh very much, a pound or two. The skin was warm and completely dry. The little head was inches from Tim's face. Its dark beady eyes stared at him. A small forked tongue flicked in and out. Will he hurt me?" "No, she's friendly." Are you sure about that?" asked Gennaro with a look of concern. "Oh, quite sure," Wu said, "at least until she grows a little older. But in any case, the babies don't have any teeth, even egg teeth." "Egg teeth?" Nedry said. Most dinosaurs are born with egg teeth, little horns at the tip of their nose, like rhino horns, to help them break out of the eggs. But raptors aren't. They poke a hole in the eggs with their pointed snouts, and then the nursery staff have to help them out." "You have to help them out?" Grant said, shaking his head. "What happens in the wild?" "In the wild?" "When they breed in the wild," Grant said. "When they make a nest." "Oh, they can't do that," Wu said. "None of our animals is capable of breeding. That's why we have this nursery. It's the only way to replace stock at Jurassic Park." "Why can't the animals breed?" "Well, as you can imagine, it's important that they not be able to breed," Wu said. "And whenever we face a critical matter such as this, we design redundant systems. That is, we always arrange at least 2 control procedures. In this case, there are 2 independent reasons why the animals can't breed. First of all, they're sterile because we irradiate them with X-rays." "And the second reason?" "Well, all the animals in Jurassic Park are female," Wu said with a pleased smile. Malcolm said, I should like some clarification about this, because it seems to me that irradiation is fraught with uncertainty. The radiation dose may be wrong or aimed at the wrong anatomical area of the animal, or... "All true," Wu said, "but we're quite confident we have destroyed gonadal tissue." "And, as for them being female," Malcolm said, "is that checked? Does anyone go out and lift up the dinosaur scratch to have a look? I mean, how does one determine the sex of a dinosaur anyway?" Sex organs vary with species. It's easy to tell on some, subtle on others. But to answer your question, the reason we know all the animals are female is that we literally make them that way. We control their chromosomes, and we control the intra-egg developmental environment. From a bioengineering standpoint, females are easier to breed. You probably know that all vertebrate embryos are inherently female. We all start life as females. It takes some kind of added effects, such as a hormone at the right moment during development, to transform the growing embryo into a male, such as the Tyrannosaurus rex. We all call it a him, but in fact they're all female, and believe me, they can't breed. The little velociraptor sniffed at Tim and then rubbed her head against Tim's neck. Tim giggled. "She wants you to feed her," Wu said. "What does she eat?" Mice, but she's just eaten, so we won't feed her again for a while. The little raptor leaned back, stared at Tim, and wiggled her forearms again in the air. Tim saw the small claws on the 3 fingers of each hand. Then the raptor burrowed her head into his neck again. Grant came over and peered critically at the creature. He touched the tiny 3-clawed hand. He said to Tim, "Do you mind?" And Tim released the raptor into his hands. Grant flipped the animal onto its back, inspecting it, while the little lizard wiggled and squirmed. Then he lifted the animal high to look in its profile, and it screamed shrilly. She doesn't like that," Regis said. "Doesn't like to be held away from body contact." The raptor was still screaming, but Grant paid no attention. Now he was squeezing the tail, feeling the bones. Regis said, "Dr. Grant, if you please." "I'm not hurting her. Dr. Grant, these creatures are not of our world. They came from a time where there were no human beings around to prod and poke them." "I'm not prodding and poke, Dr. Grant." "Put her down, now," Ed Regis said. "But now." Regis was starting to get annoyed. Grant handed the animal back to Tim. It stopped squealing. Tim could feel its little heart beating rapidly against his chest. "I'm sorry, Dr. Grant," Regis said, "but these animals are delicate in infancy. We have lost several from postnatal stress syndrome, which we believe is adrenocortically mediated. Sometimes they die within 5 minutes. Tim petted the little raptor. "It's okay, kid," he said. "Everything's fine now." The heart was still beating rapidly. "We feel it's important that the animals here be treated with the most humane manner," Regis said. "I promise you that you will have every opportunity to examine them later." But Grant couldn't stay away. He again moved toward the animal and Tim's arms, peering at it. The little velociraptor opened her jaws and hissed at Grant in a posture of sudden intense fury. "Fascinating," Grant said. "Can I stay and play with her?" Tim said. "Not right now," Ed Regis said, glancing at his watch. "It's 3 o'clock and it's time for a tour of the park itself so you can see all the dinosaurs and the habitats we have designed for them." Tim released the velociraptor, which scampered across the room, grabbed a cloth rag, put it in her mouth, and tugged at the end with her tiny claws. Control. Walking back towards the control room, Malcolm said, I have one more question, Dr. Wu. How many species have you made so far?" "I'm not exactly sure," Wu said. "I believe the number at the moment is 15. 15 species. Do you know, Ed?" Yes, it's 15, Ed Regis said, nodding. You don't know for sure?" Malcolm said, affecting astonishment. Wu smiled. "I stopped counting," he said, "after the first dozen, and you have to realize that sometimes we think we have an animal correctly made from the standpoint of the DNA, which is our basic work, and the animal grows for 6 months, and then something untoward happens. And we realize there is some error, a releaser gene isn't operating, a hormone not being released, or some other problem in the developmental sequence. So we have to go back to the drawing board with that animal, so to speak." He smiled. "At the time I thought we had more than 20 species, but now only 15. "And is one of those 15 species, Malcolm turned to Grant. What was the name?" "Procompsognathus," Grant said. Have you made some Procompsognathuses or whatever they're called?" Malcolm asked. "Oh, yes," Wu said immediately. "Compies are very distinctive animals, and we made an unusually large number of them." Why is that?" "Well, we want Jurassic Park to be as real an environment as possible, as authentic as possible, and the Procompsognathids are actual scavengers from the Jurassic period, rather like jackals, so we wanted to have some compies around to clean up." "You mean to, dispose of carcasses?" "Well, yes, if there are any. But with only 230-odd animals in our total population, we don't have many carcasses," Wu said. "That wasn't the primary objective. Actually, we wanted the compies for another kind of waste management entirely." "Which was?" "Well," Wu said, "we have some very big herbivores on the island. We have specifically tried not to breed the largest sauropods, and even so, we've got several animals in excess of 30 tons walking around out there. And many others in the 5 to 10 ton area. That gives us 2 problems. One is feeding them, and in fact we must import food to the island every 2 weeks. There is no way an island this small can support these animals for any time. But the other problem is waste. I don't know if you've ever seen elephant droppings," Wu said, "but they are substantial. Each spore is roughly the size of a soccer ball. Imagine the droppings of a brontosaur 10 times as large. Now imagine the droppings of a herd of such animals as we keep here. And the largest animals do not digest their food terribly well, so they excrete a great deal. And in the 60 million years since dinosaurs disappeared, apparently the bacteria that specialize in breaking down their feces, they disappeared too. At least the sauropod feces don't dispose readily. That's a problem, Malcolm said. I assure you it is, Wu said, not smiling. We had a hell of a time trying to solve it. You probably know that in Africa there is a specific insect, the dung beetle, which eats elephant feces. Many other large species have associated creatures that have evolved to eat their excrement. Well, it turns out that compies will eat the feces of large herbivores and redigest it, and the droppings of compies are readily broken down by contemporary bacteria, so given enough compies, our problem was solved. How many compies did you make? I've forgotten exactly, but I think the target population was 50 animals, and we attained that, and very nearly so, in 3 batches. We did a batch every 6 months until we had the number. 50 animals, Malcolm said, is a lot to keep track of. The control room is built to do exactly that. They'll show you how it's done. I'm sure, Malcolm said, but if one of these compies were to escape from the island to get away, they can't get away. Well, I know that, but just supposing one did. You mean like the animal that was found on the beach, Wu said, raising his eyebrows. The one that bit the American girl. Well, yes, for example. I don't know what the explanation for that animal is, Wu said, but I know it can't possibly be one of ours for 2 reasons. First, the control procedures our animals are counted by a computer every few minutes. If one were missing, we know at once. And the second reason? The mainland is more than 100 miles away. It takes almost a day to get there by boat, and in the outside world, our animals will die within 12 hours, Wu said. How do you know? Because I've made sure that's precisely what will occur, Wu said, finally showing a trace of irritation. Look, we're not fools. We understand these are prehistoric animals. They are part of a vanished ecology, a complex web of life that became extinct millions of years ago. They might have no predators in the contemporary world, no checks on their growth. We don't want them to survive in the wild, so I made them lysine dependent. I inserted a gene that makes a single faulty enzyme in protein metabolism. As a result, the animals cannot manufacture the amino acid lysine. They must ingest it from the outside unless they get a rich dietary source of exogenous lysine supplied by us in tablet form. They'll go into a coma within 12 hours and expire. These animals are genetically engineered to be unable to survive in the real world. They can only live here in Jurassic Park. They are not free at all. They are essentially our prisoners. Here's the control room, Ed Regis said. Now that you know how the animals are made, you'll want to see the control room for the park itself. Before we go out on the... He stopped. Through the thick glass window, the room was dark. The monitors were off except for 3 that displayed spinning numbers in the image of a large boat. What's going on? Regis said. Hell, they're docking. Docking? Every few weeks, the supply boat comes in from the mainland. One of the things this island doesn't have is a good harbor or even a good dock. It's a little hairy to get the ship in when the seas are rough. Could be a few minutes. He rapped on the window, but the men inside paid no attention. I guess we'll have to wait then. Ellie turned to Dr. Wu. You mentioned before that sometimes you make an animal and it seems to be fine, but as it grows it shows itself to be flawed. Well, yes, Wu said. I don't think there's any way around that. We can duplicate the DNA, but there's a lot of timing and development, and we don't know if everything is working unless we actually see an animal develop correctly. Grant said, How do you know if it's developing correctly? No one has ever seen these animals before. Wu smiled. I have often thought about that. I suppose it is a bit paradox. Eventually, I hope paleontologists such as yourself will compare our animals with the fossil record to verify the developmental sequence. Ellie said, But the animal we just saw, the velociraptor, you said it was a Mongoliensis? From the location of the amber, Wu said, it is from China. Interesting, Grant said. I was just digging up an infant Anthropus. Are there any fully grown raptors here? Well, yes, Ed Regis said without hesitation. 8 adult females. The females are the real hunters. They're pack hunters, you know? Or we see them on the tour? No. Wu said, looking suddenly uncomfortable, and then there was an awkward pause. Wu looked at Regis. Not for a while, Regis said cheerfully. The velociraptors haven't been integrated into the park setting just yet. We keep them in the holding pen. Can I see them there? Grant said. Why, yes, of course. In fact, while we're waiting, he glanced at his watch, you might want to go around and have a look at them. I certainly would, Grant said. Absolutely, Ellie said. I want to go too, Tim said eagerly. Just go around the back of the building, past the support facility, and you'll see the pen. Just don't get too close to the fence. You want to go too? He said to the girl. No, Lex said. She looked appraisingly at Regis. You want to play a little pickle? Throw a few? Well, sure, Ed Regis said. Why don't you and I go downstairs and we'll do that while we wait for the control room to open up. Grant walked with Ellie and Malcolm around the back of the main building with the kid tagging along. Grant liked kids. It was impossible not to like any group so openly enthusiastic about dinosaurs. Grant used to watch kids in museums as they stared open-mouthed at the big skeletons rising above them. He wondered what their fascination really represented. He finally decided that children liked dinosaurs because these giant creatures personified the uncontrollable force of looming authority. They were symbolic parents, fascinating and frightening, like parents. And kids loved them as they loved their parents. Grant also suspected this was why even young children learned the names of dinosaurs. It never failed to amaze him when a 3-year-old shrieked, Stegosaurus! Saying these complicated names was a way of exerting power over the giants, a way of being in control. So, what do you know about Velociraptor? Grant asked Tim. He was just making a conversation. It's a small carnivore that hunted in packs, like Deinonychus, Tim said. That's right, Grant said. Although the evidence for pack hunting is all circumstantial. You see, it derives in part from the appearance of the animals, which are quick and strong but small for dinosaurs, just 150 to 300 pounds each. We assume they hunted in groups if they were to bring down larger prey. And if there are some fossil finds in which a single large prey animal is associated with several raptor skeletons, it's suggested they hunted in packs. And of course, raptors were large-brained, more intelligent than most dinosaurs. How intelligent is that? Malcolm asked. Depends on who you talk to, Grant said. Just as paleontologists have come around to the idea that dinosaurs were probably warm-blooded, a lot of us are starting to think that some of them might have been quite intelligent too, but nobody knows for sure. They left the visitor area behind, and soon they heard the loud hum of generators, smelled the faint odor of gasoline. They passed a grove of palm trees and saw a large, low concrete shed with a steel roof. The noise seemed to come from there. They looked in the shed. It must be a generator, Ellie said. It's big, Grant said, peering inside. The power plant actually extended 2 stories below ground level, a vast complex of winding turbines and piping that ran down in the earth lit by harsh electric bulbs. They can't need all this for just a resort, Malcolm said. They're generating enough power here for a small city. Maybe for the computers. Maybe. Grant heard bleating and walked north a few yards. He came to an animal enclosure with goats. By quick count, he estimated there were 50 or 60 goats. What's that for? Ellie said. Beats me. Probably feed them to the dinosaurs, Malcolm said. The group walked on, following a dirt path through a dense bamboo grove. At the far side, they came to a double-layered chain-link fence 12 feet high, with spirals of barbed wire at the top. There was an electric hum along the outer fence. Beyond the fences, Grant saw dense clusters of large ferns, 5 feet high. He heard a snorting sound, a kind of snuffling, then the sound of crunching footsteps coming closer. Then a long silence. I don't see anything, Tim whispered finally. Shh! Grant waited. Several seconds passed. Flies buzzed in the air. He still saw nothing. Ellie tapped him on the shoulder and pointed. Amid the ferns, Grant saw the head of an animal. It was motionless, partially hidden in the fronds, the 2 large dark eyes watching them coldly. The head was 2 feet long. From a pointed snout, a long row of teeth ran back to the hole of the auditory meatus which served as an ear. The head reminded him of a large lizard or perhaps a crocodile. The eyes did not blink, and the animal did not move. Its skin was leathery with a pebble texture, and basically the same coloration as the infant's. Yellow-brown with the darker reddish markings, like the stripes of a tiger. As Grant watched, a single forearm reached up very slowly to part the ferns between the animal's face. The limb, Grant saw, was strongly muscled. The hand had 3 grasping fingers, each ending in curved claws. The hand gently, slowly pushed aside the ferns. Grant felt a chill and thought, "He's hunting us." For a mammal like man, there was something indescribably alien about the way reptiles hunted their prey. No wonder men hated reptiles. The stillness, the coldness, the pace was all wrong. To be among alligators or other large reptiles was to be reminded of a different kind of life, a different kind of world now vanished from the earth. Of course, this animal didn't realize that he had been spotted, The attack came suddenly from the right and the left. Charging raptors covered the 10 yards to the fence with shocking speed. Grant had a blurred impression of powerful 6-foot-tall bodies, stiff balancing tails, limbs with curving claws, open jaws with rows of jagged teeth. The animals snarled as they came forward and then leapt bodily into the air, raising their hind legs with their big dagger claws. Then they stuck to the fence in front of them, throwing off twin bursts of hot sparks. The velociraptors fell backward to the ground, hissing. The visitors all moved forward, fascinating. Only then did the third animal attack, leaping up to strike the fence at chest level. Tim screamed in fright as the sparks exploded all around him. The creature snarled, a low reptilian hissing sound, and leapt back among the ferns. Then they were gone, leaving behind a faint odor of decay and hanging acrid smoke. "Holy shit," Tim said. "It was so fast," Ellie said. "Pack hunters," Grant said, shaking his head. "Pack hunters for whom ambush is an instinct." Fascinating. I wouldn't call them, tremendously, intelligent, Malcolm said. On the other side of the fence, they heard snorting in the palm trees. Several heads poked slowly out of the foliage. Grant counted 3, 4, 5. The animals watched them, staring coldly. A black man in coveralls came running up to him. "You all right?" We're okay," Grant said. "The alarms were set off." The man looked at the fence, dented and charred. "They attacked you?" 3 of them did, yes." The black man nodded. "Yeah, they do that all the time. Hit the fence, take a shock. They never seem to mind." Not too smart, are they?" Malcolm said. The black man paused. He squinted at Malcolm in the afternoon light. "Be glad for that fence, senor," he said, and turned away. From beginning to end, the entire attack could not have taken more than 6 seconds. Grant was still trying to organize his impressions. The speed was astonishing. The animals were so fast, he had hardly seen them move. Walking back, Malcolm said, "They're, remarkably fast." "Yes," Grant said, "much faster than any living reptile. A bull alligator can move quickly, but only over a short distance, 5 or 6 feet. Big lizards like the 5-foot Komodo dragons of Indonesia have been clocked at 30 miles an hour, fast enough to run down a man. And they kill men all the time, but I guess the animal behind the fence was more than twice that fast." "Cheetah speed," Malcolm said. 60, 70 miles an hour. "Exactly. But they seem to dart forward," Malcolm said, "rather like birds?" "Yes." In the contemporary world, only very small mammals like the cobra-fighting mongoose had such quick responses. Small mammals and, of course, birds. The snake-hunting secretary bird of Africa, or the cassowary. In fact, the velociraptor conveyed precisely the same impression of deadly swift menace Grant had seen in the cassowary, the clawed ostrich-like bird of New Guinea. So these velociraptors look like reptiles, with the skin and general appearance of reptiles, but they move like birds with the speed and the predatory intelligence of birds. Is that about it? Malcolm said. "Yes," Grant said. "I'd say they display a mixture of traits." "Does that surprise you?" "Not really," Grant said. "It's actually rather close to what paleontologists believed a long time ago. When the first giant bones were found in the 1820s and 1830s, scientists felt obliged to explain the bones as belonging to some oversized variant of a modern species. This was because it was believed that no species could ever become extinct, since God would not allow one of his creations to die. Eventually, it became clear that this conception of God was mistaken, and the bones belonged to extinct animals. But what kind of animals? In 1842, Richard Owen, the leading British anatomist of the day, called them Dinosauria, meaning terrible lizards. Owen recognized that the dinosaurs seemed to combine traits of lizards, crocodiles, and birds. In particular, dinosaur hips were bird-like, not lizard-like, and unlike lizards, many dinosaurs seemed to stand upright. Owen imagined dinosaurs to be quick-moving, active creatures, and his view was accepted for the next 40 years. But when truly gigantic finds were unearthed, animals that had weighed 100 tons in life, scientists began to envision the dinosaurs as stupid, slow-moving giants destined for extinction. The image of the sluggish reptile gradually predominated over the image of the quick-moving bird. In recent years, scientists like Grant had begun to swing back towards the idea of more active dinosaurs. Grant's colleagues saw him as radical in his conception of dinosaur behavior, but now he had to admit his own conception had fallen far short of the reality of these large, incredibly swift hunters. Actually, what I was driving at, Malcolm said, was this: is it a persuasive animal to you? Is it in fact a dinosaur? I'd say so, yes. And the coordinated attack pattern? To be expected, Grant said. According to the fossil record, packs of velociraptors were capable of bringing down animals that weighed 1,000 pounds like Tyrannosaurus, which could run as fast as a horse. Coordination would be required. How do they do that without a language? Oh, language isn't necessary for coordinated hunting, Ellie said. Chimpanzees do it all the time. Group of chimps will stalk a monkey and kill it. All communication is by eyes. And were the dinosaurs in fact attacking us? Yes. They would kill us and eat us if they could, Malcolm said. I think so. The reason I ask, Malcolm said, is that I'm told large predators such as lions and tigers are not born man-eaters. Isn't that true? These animals must learn somewhere along the way that human beings are easy to kill. Only afterward do they become man-killers. Yes, I believe that's true, Grant said. Well, these dinosaurs must be even more reluctant than lions and tigers. After all, they come from a time before human beings or even large animals existed at all. God knows what they think when they see us. So I wonder, have they learned somewhere along the line that humans are easy to kill? The group fell silent as they walked. In any case, Malcolm said, I shall be extremely interested to see the control room. Version 4.4. Was there any problem with the group? No, Henry Wu said. There was no problem at all. They accepted your explanation. Why shouldn't they? Wu said. It's all quite straightforward in the broad strokes. It's only the details that get sticky. And I wanted to talk about the details with you today. You can think of it as a matter of aesthetics. John Hammond wrinkled at his nose as if he smelled something disagreeable. Aesthetics, he repeated. They were standing in the living room of Hammond's elegant bungalow set back among palm trees in the northern sector of the park. The living room was airy and comfortable, fitted with a half-dozen video monitors showing the animals in the park. The file Wu had brought, stamped Animal Development Version 4.4, lay on the coffee table. Hammond was looking at him in that patient, paternal way. Wu, 33 years old, was acutely aware that he had worked for Hammond all his professional life. Hammond had hired him right out of graduate school. Of course, there are practical consequences as well, Wu said. I really think you should consider my recommendations for Phase 2. We should go to version 4.4. You want to replace all the current stock of animals? Hammond said. Yes, I do. Why? What's wrong with them? Nothing, Wu said, except they're real dinosaurs. Well, that's what I asked for, Henry, Hammond said, smiling. And that is what you gave me. I know, Wu said, but you see... He paused. How could he explain this to Hammond? Hammond hardly ever visited the island, and it was a peculiar situation that Wu was trying to convey. Right now, as we stand here, almost no one in the world has ever seen an actual dinosaur. Nobody knows what they're really like. Yes. The dinosaurs we have now are real, Wu said, pointing to the screens around the room. But in certain ways they are unsatisfactory, unconvincing. I could make them better. Better in what way? For one thing, they move too fast, Henry Wu said. People aren't accustomed to seeing large animals that are so quick. I'm afraid visitors will think the dinosaurs look speeded up, like film running too fast. Oh, but Henry, you said these were real dinosaurs. You said so yourself. I know, Wu said, but we can easily breed slower, more domesticated dinosaurs. Domesticated dinosaurs, Hammond snorted. Nobody wants domesticated dinosaurs, Henry. They want the real thing. But that's my point, Wu said. I don't think they do. They want to see their expectation with it. It's quite different. Hammond was frowning. You said so yourself, John. This park is entertainment, Wu said. And entertainment has nothing to do with reality. Entertainment is antithetical to reality. Hammond sighed. Now, Henry, are we going to have another one of those abstract discussions? You know I like to keep it simple. The dinosaurs we have now are real and... Well, not exactly, Wu said. He paced the living room, pointed to the monitors. I don't think we should kid ourselves. We haven't recreated the past here. The past is gone. It can never be recreated. What we've done is reconstruct the past, or at least a version of the past. And I'm saying we can make a better version. Better than real. Why not? Wu said. After all, these animals are already modified. We've inserted genes to make them patentable, to make them lysine dependent, and we've done everything we can to promote growth and accelerate development into adulthood. Hammond shrugged. That was inevitable. We didn't want to wait. We have investors to consider. Of course, but I'm just saying, why stop there? Why not push ahead to make exactly the kind of dinosaur that we'd like to see? One that is more acceptable to visitors, one that is easier for us to handle, a slower, more docile version of our park. Hammond frowned. But then the dinosaurs wouldn't be real. But they're not real now, Wu said. That's what I'm trying to tell you. There isn't any reality here. He shrugged helplessly. He could see he wasn't getting through. Hammond had never been interested in technical details, and the essence of the argument was technical. How could he explain to Hammond about the reality of DNA dropouts, the patches, the gaps in the sequence that Wu had been obliged to fill in, making the best guesses he could, but still making guesses? The DNA of the dinosaurs was like old photographs that had been retouched, basically the same as the original, but in some places repaired and clarified, and as a result... Now, Henry, Hammond said, putting his arm around Wu's shoulder, if you don't mind my saying so, I think you're getting cold feet. You've been working very hard for a long time, and you've done a hell of a job. And it's finally time to reveal to some people what you've done. It's natural to be a little nervous, to have some doubts, but I am convinced, Henry, that the world will be entirely satisfied. As he spoke, Hammond steered him towards the door. But John, Wu said, remember back in 87 when we started to build the containment devices? We didn't have any full-grown adults yet, so we had to predict what we'd need. We ordered big taser shockers, cars with cattle prods mounted on them, guns that blow out electric nets, all built specifically to our specifications. We've got a whole array of devices now, and they're all too slow. We've got to make some adjustments. You know that Muldoon wants military equipment. Law missiles and laser-guided devices? Let's leave Muldoon out of this, Hammond said. I'm not worried. It's just a zoo, Henry. The phone rang and Hammond went to answer it. Wu tried to think of another way to press his case, but the fact was, after 5 long years, Jurassic Park was nearing completion, and John Hammond just wasn't listening to him anymore. There had been a time when Hammond listened to Wu very attentively, especially when he had first recruited him, back in the days when Henry Wu was a 28-year-old graduate student getting his doctorate at Stanford in Norman Atherton's lab. Atherton's death had thrown the lab into confusion as well as mourning. No one knew what would happen to the funding or the doctoral programs. There was a lot of uncertainty, people worried about their careers. 2 weeks after the funeral, John Hammond came to see Wu. Everyone in the lab knew that Atherton had some association with Hammond, although the details were never clear, but Hammond had approached Wu with a directness Wu would never forget. No, Norman always said you're the best geneticist in his lab, he said. What are your plans now? I don't know, research? You want a university appointment? Yes. That's a mistake, Hammond said briskly. At least, if you respect your talent. Wu had blinked. Why? Because, let's face facts, Hammond said. Universities are no longer the intellectual centers of the country. The very idea is preposterous. Universities are the backwater.
Oh, don't look so surprised. I'm not saying anything you don't know. Since World War II, all the really important discoveries have come out of private laboratories. The laser, the transitor, the polio vaccine, the microchip, the hologram, the personal computer, magnetic resonance imaging, CAT scans, the list goes on and on. Universities simply aren't where it's happening anymore, and they haven't been for 40 years. If you want to do something important in computers or genetics, don't go to a university, damn it, no.
Wu found he was speechless. Good heavens, Hammond said. What must you go through to start a new project? How many grant applications, how many forms, how many approvals, the steering committee, the department chairman, the university resources committee. How do you get more workspace if you need it? More assistants if you need them? How long does all that take? A brilliant man can squander precious time with forms and committees? Life is too short and DNA too long. You want to make your mark. If you want to get something done, stay out of universities. In those days, Wu desperately wanted to make his mark. John Hammond had his full attention. I'm talking about work, Hammond continued. Real accomplishment. What does a scientist need to work? He needs time, and he needs money. I'm talking about giving you a 5-year commitment and $10 million a year in funding. $50 million and no one tells you how to spend it. You decide. Everyone else just gets out of your way. It sounded too good to be true. Wu was silent for a long time. Finally he said, in return for what? For taking a crack at the impossible, Hammond said. For trying something that probably can't be done. What does it involve? Well, I can give you details, but the general area involves cloning reptiles. I don't think that's impossible, Wu said. Reptiles are easier than mammals. Cloning's probably only 10-15 years off, assuming some fundamental advances. I've got 5 years, Hammond said, and a lot of money for somebody who wants to take a crack at it now. Is my work publishable? Eventually. Not immediately? No. But eventually publishable, Wu asked, sticking to this point. Hammond had laughed. Don't you worry. If you succeed, the whole world will know what you've done. I promise you. And now it seemed like the whole world would indeed know, Wu thought. After 5 years of extraordinary effort, they were just a year away from opening the park to the public. Of course, those years hadn't gone exactly as Hammond had promised. Wu had some people telling him what to do, and many times fearsome pressures were placed on him, and the work itself had shifted. It wasn't even reptilian cloning once they began to understand that dinosaurs were so similar to birds. It was avian cloning, a very different proposition, much more difficult. And for the last 2 years, Wu had been primarily an administrator, supervising teams of researchers and banks of computer-operated gene sequencers. Administration wasn't the kind of work he relished. It wasn't what he had bargained for. Still, he had succeeded. He had done what nobody really believed could be done, at least in so short a time, and Henry Wu thought that he should have some rights, some say, in what happened by virtue of his expertise at his efforts. Instead, he found his influence waning with each passing day. The dinosaurs existed. The procedures for obtaining them were working out to the point of being routine. The technologies were mature, and John Hammond didn't need Henry Wu anymore. That should be fine, Hammond said, speaking into the phone. He listened for a while and smiled at Wu. Oh, fine, yes, fine. He hung up. Where were we, Henry? We were talking about Phase 2, Wu said. Oh, yes. We've gone over some of this before, Henry. I know, but you don't realize... Excuse me, Henry, Hammond said with an edge of impatience in his voice. I do realize. And I must tell you frankly, Henry, I see no reason to improve upon reality. Every change we've made in the genome has been forced on us by law or necessity. We may make other changes in the future to resist diseases or for some other reasons, but I don't think we should improve upon reality just because we think it's better that way. We have real dinosaurs out there now. That is what people want to see, and that's what they should see. That is our obligation, Henry. That's honest Henry. And smiling, Hammond opened the door for him to leave. Control. Grant looked at all the computer monitors in the darkened control room, feeling irritable. Grant didn't like computers. He knew that this made him old-fashioned, dated as a researcher, but he didn't care. Some of the kids who worked for him had a real feeling for computers and intuition. Grant never felt that. He found computers to be alien, mystifying machines. Even the fundamental distinction between an operating system and an application left him confused and disheartened, literally lost in a foreign geography he didn't begin to comprehend. But he noticed that Gennaro was perfectly comfortable and Malcolm seemed to be in his element, making little sniffing sounds like a bloodhound on a trail. "You want to know about the control mechanisms," John Arnold said, turning in his chair in the control room. The head engineer was a thin, tense, chain-smoking man of 45. He squinted at the others in the room. "We have unbelievable control mechanisms," Arnold said and lit another cigarette. For example," Gennaro said. "For example, animal tracking." Arnold pressed a button on his console and the vertical glass map lit up with a pattern of jagged blue lines. "That is our juvenile T-Rex, the Little Rex, all his movements within the park over the last 24 hours. Arnold pressed the button again. Previous 24, and again. Previous 24. The line on the map became densely overlaid, a child's scribble, but the scribble was localized in a single area near the southeast side of the lagoon. "You get a sense of his home range over time," Arnold said. "He's young, so he stays close to the water, and he stays away from the big adult Rex. You put up the big Rex and the Little Rex and you'll see their paths never cross." Where is the big Rex right now?" Gennaro asked. Arnold pushed another button. The map cleared and a single glowing spot with a code number appeared in the fields northwest of the lagoon. "He's right there." "And the Little Rex?" "Hell, I'll show you every animal in the park," Arnold said. The map began to lit up like a Christmas tree, dozens of spots of light, each tagged with a code number. "That's 238 animals as of this minute." "How accurate?" "Within 5 feet. Arnold puffed on the cigarette. "Let's put it this way. You drive out in a vehicle and you will find the animals right there exactly as they're shown on the map." "How often is this updated?" "Every 30 seconds. "Pretty impressive," Gennaro said. "How's it done?" "We have motion sensors all over the park," Arnold said. "Most of them hardwired, some radio telemetried. Of course, motion sensors won't usually tell you the species, but we get image recognition directly off the video. Even when we're not watching the video monitors, the computer is, and checking where everybody is." "Does the computer ever make a mistake?" "Only with the babies. It mixes those up sometimes because they're such small images, but we don't sweat it. The babies almost always stay close to the herds of adults. You have the category tally." "What's that?" "Once every 15 minutes, the computer tallies up the animals in all categories," Arnold said. "Like this." "What you see here," Arnold said, "is an entirely separate counting procedure. It isn't based off the tracking data. It's a fresh look. The whole idea is that the computer can't make a mistake because it compares two different ways of gathering the data. If an animal were missing, we'd know about it within 5 minutes. I see, Malcolm said. "And has that ever actually been tested?" "Well, in a way," Arnold said. "We've had a few animals die. An Elfnelian got caught in the branches of a tree and strangled. One of the Stegos died of that intestinal illness that keeps bothering him. One of the Hypsilophodons fell and broke his neck. And in each case, once the animal stopped moving, the number stopped tallying and the computer signaled an alert." "Within 5 minutes?" "Yes." Grant said, "What is the right-hand column?" "Release version for the animals. The most recent are version 4.1 or 4.3. We're considering going to version 4.4. "Version numbers? You mean like software? New releases?" "Well, yes," Arnold said. "It is like software in a way. As we discovered the glitches in the DNA, Dr. Wu's labs have to make a new version." The idea of living creatures being numbered like software, being subject to updates and revisions, troubled Grant. He could not exactly say why. It was too new of a thought. But he was instinctively uneasy about it. They were, after all, living creatures. Arnold must have noticed his expression because he said, "Look, Dr. Grant, there's no point getting starry-eyed about these animals. It's important for everyone to remember that these animals are created by man. Sometimes there are bugs, so as we discover the bugs, Dr. Wu's labs have to make a new version, and we need to keep track of what version we have out there." Yes, of course you do," Malcolm said impatiently, but going back to the matter of counting, I take it all the counts are based on motion sensors?" "Yes. And those motion sensors are everywhere in the park. They cover 92% of the land area," Arnold said. "There are only a few places we can't use them."
For example, we can't use them on the Jungle River because the movement of the water and the convection rising from the surface screws up the sensors. But we have them nearly everywhere else. And if the computer tracks an animal into an uncensored zone, it will remember and look for the animal to come out again. And if it doesn't, gives us an alarm. Now then, Malcolm said, if you show 49 procompsognathids, suppose I suspect that some of them aren't really the correct species. How would you show me that I'm wrong? 2 ways, Arnold said. First of all, I can track individual movements against the other presumed compies. Compies are social animals. They move in a group. We have 2 compy groups in the park, so the individual should be within either Group A or Group B. Yes, but the other way is direct visual, he said. He punched buttons and one of the monitors began to flicker rapidly through images of compies numbered from 1 to 49. These pictures are current ID images from within the last 5 minutes. So you can see all the animals if you want to. Yes, and I can visually review all the animals whenever I want. How about physical containment, Gennaro said. Can I get out of their enclosures? Absolutely not, Arnold said. These are expensive animals, Mr. Gennaro. We take very good care of them. We maintain multiple barriers, first the moats. He pressed a button and the board lit up with a network of orange bars. These moats are never less than 12 feet deep and water-filled. For bigger animals, the moats may be 30 feet deep. Next, the electrified fences. Lines of bright red glowed on the board. We have 50 miles of 12-foot high fencing, including 22 miles around the perimeter of the island. All the park fences carry 10,000 volts. The animals quickly learn not to go near them. But if one did get out? Arnold snorted and snuffed out his cigarette. Well, just hypothetically, Gennaro said, supposing it happened? Muldoon cleared his throat. He'd go out and get the animal back, he said. We have lots of ways to do that. Taser shotguns, electrified nets, tranquilizers, all non-lethal because, as Mr. Arnold says, these are expensive animals. Gennaro nodded. And if one got off the island? It'd die within less than 24 hours, Arnold said. These are genetically engineered animals. They're unable to survive in the real world. How about this control system itself, Gennaro said. Could anybody tamper with it? Arnold was shaking his head. The system is hardened. The computer is independent in every way. Independent power and independent backup power. The system does not communicate with the outside, so it cannot be influenced remotely by a modem. The computer system is secure. There was a pause. Arnold puffed his cigarette. Hell of a system, he said. Hell of a goddamn system. Then I guess you're right, Malcolm said. Your system works so well that you don't have any problems. We got endless problems here, Arnold said, raising an eyebrow. But none of the things you worry about. I gather you're worried that the animals will escape and get to the mainland and raise hell. We haven't got any concern about that at all. We see these animals as fragile and delicate. They've been brought back after 65 million years to a world that's very different from the one they left, the one they were adapted to. We have a hell of a time caring for them. You have to realize, Arnold continued, that men have been keeping mammals and reptiles in zoos for hundreds of years, so we know a lot about how to take care of an elephant or a croc, but nobody has ever tried to take care of a dinosaur before. They are new animals, and we just don't know. Diseases in our animals are the biggest concern. Diseases? Gennaro said, suddenly alarmed. Is there any way that a visitor can get sick? Arnold snorted again. You ever catch a cold from a zoo alligator, Mr. Gennaro? Zoos don't worry about that, neither do we. What we do worry about is the animals dying from their own illnesses or infecting other animals, but we have the programs to monitor that too. You want to see the Big Rex's health file? His vaccination record? His dental record? That's something. You ought to see the vet scrubbing those big fangs so he doesn't get tooth decay. Not just now, Gennaro said. What about your, mechanical systems? You mean the rides, Arnold said. Grant looked up sharply. Rides? None of the rides are running yet, Arnold was saying. We have the Jungle River ride where the boats follow tracks underwater, and we have the Every Lodge ride, but none of it's operational yet. The park will open with the basic dinosaur tour, the one that you're about to take in a few minutes. The other ride will come on line 6, 12 months after that. Wait a minute, Grant said. You're going to have rides? Like an amusement park? Arnold said, this is a zoological park. We have tours of different areas, and we call them rides, that's all. Grant frowned. Again, he felt troubled. He didn't like the idea of dinosaurs being used for an amusement park. Malcolm continued his questions. You can run the whole park from the control room? Yes, Arnold said. I can run it single-handedly if I have to. We got that much automation built in. The computer by itself can track the animals, feed them, and fill their water troughs for 48 hours without supervision. This is the system that Mr. Nedry. This is the system that Mr. Nedry designed? Malcolm asked. Dennis Nedry was sitting at a terminal in the far corner of the room, eating a candy bar and typing. Yes, that's right, Nedry said, not looking up from the keyboard. It's a hell of a system, Arnold said proudly. That's right, Nedry said absently. Just one or two minor bugs to fix. Now, Arnold said, I see the tour is starting, so unless you have any other questions. Actually, just one, Malcolm said, just a research question. You showed us that you can track the procompsognathids and you can visually display them individually. Can you do any studies of them as a group? Measure them or whatever? If I wanted to know the height or weight or... Arnold was punching buttons. Another screen came up. We can do all that very quickly, Arnold said. The computer takes measurement data in the course of the reading the video screen, so it's translatable at once. You see here we have a normal poison distribution for the animal population. It shows that most of the animals cluster around an average central value, and a few are either larger or smaller than the average at the tails of the curve. You'd expect that kind of graph, Malcolm said. Yes, any healthy biological population shows this kind of distribution. Now then, Arnold said, lighting another cigarette. Are there any other questions? No, Malcolm said. I've learned what I needed to know. As they were walking out, Gennaro said, Looks like a pretty good system to me. I don't see how any animals could get off this island. Don't you? Malcolm said. I thought it was completely obvious. Wait a minute, Gennaro said. You think animals have gotten out? I know they have. Gennaro said, But how? You saw for yourself. They can count all the animals. They can look at all the animals. They know where all the animals are at all times. How can one possibly escape? Malcolm smiled. It's quite obvious, he said. It's just a matter of your assumptions. Your assumptions, Gennaro repeated, frowning. Yes, Malcolm said. Look here. The basic event that has occurred in Jurassic Park is that the scientists and the technicians have tried to make a new, complete biological world. And the scientists in the control room expect to see a natural world, as in the graph they just showed us, even though a movement's thoughts reveal that nice, normal distribution is terribly worrisome on this island. It is? Yes, based on what Dr. Wu told us earlier, one should never see a population graph like that. Why not, Gennaro said. Because that is a graph for a normal biological population, which is precisely what Jurassic Park is not. Jurassic Park is not the real world. It is intended to be a controlled world that only imitates the natural world. In that sense, it's a true park, rather like a Japanese formal garden. Nature manipulated to be more natural than the real thing, if you will. I'm afraid you lost me, Gennaro said, looking annoyed. I'm sure the tour will make everything clear, Malcolm said. The tour. This way, everybody. This way, Ed Regis said. By his side, a woman was passing out pith helmets with Jurassic Park labeled on the headband and a little blue dinosaur logo. A line of Toyota Land Cruisers came out of an underground garage beneath the visitor center. Each car pulled up, driverless and silent. 2 black men in safari uniforms were opening the doors for passengers. 2 to 4 passengers to a car, please. 2 to 4 passengers to a car, please, a recorded voice was saying. Children under 10 must be accompanied by an adult. 2 to 4 passengers to a car, please. Tim watched as Grant, Sattler, and Malcolm got into the first Land Cruiser with the lawyer, Gennaro. Tim looked over at Lex, who was standing, pounding her fist into her glove. Tim pointed to the first car and said, Can I go with them? I'm afraid they have things to discuss, Ed Regis said. Technical things. I'm interested in technical things, Tim said. I'd rather go with them. Well, you'll be able to hear what they're saying, Ed Regis said. We have a radio open between the cars. The second car came. Tim and Lex got in, and Ed Regis followed. These are electric cars, Regis said, guided by a cable in the roadway. Tim was glad he was sitting in the front seat because mounted in the dashboard were 2 computer screens and a box that looked to him like a CD-ROM. That was a laser disc player controlled by a computer. There was also a portable walkie-talkie and some kind of radio transmitter. There were 2 antennas on the roof and some odd goggles in the map pocket. The black men shut the doors of the Land Cruiser. The car started off with an electric hum.
Up ahead, the three scientists and Gennaro were talking and pointing, clearly excited. Ed Regis said, "Let's hear what they're saying." An intercom clicked.
I don't know what the hell you think they're doing here,
Gennaro said over the intercom. He sounded very angry.
I know quite well why I'm here.
Malcolm said.
You're here to advise me, not play goddamn mind games. I got 5% of this company and a responsibility to make sure that Hammond has done his job responsibly. Now you goddamn come here.
Ed Regis pressed the intercom button and said, "In keeping with non-polluting policies of Jurassic Park, these lightweight electric Land Cruisers have been specifically built for us by Toyota in Osaka. Eventually we hope to be driving among the animals, just as they do in African game parks. But for now, sit back and enjoy the self-guided tour." He paused. "And by the way, we can hear you back there." "Oh Christ," Gennaro said. "I have to be able to speak freely. I didn't ask for these damn kids to come." Ed Regis smiled blandly and pushed a button. "We'll just begin the show, shall we?" They heard a fanfare of trumpets and the interior screens flashed, "Welcome to Jurassic Park." A sonorous voice said, "Welcome to Jurassic Park. You are now entering the lost world of the prehistoric past, a world of mighty creatures long gone from the face of the earth, which you are privileged to see for the first time." "That's Richard Kiley," Ed Regis said. "We spared no expense." The Land Cruiser passed through a grove of low, stumpy palm trees. Richard Kiley was saying, "Notice, first of all, the remarkable plant life that surrounds you. Those trees to your left and right are called cycads, the prehistoric predecessors of palm trees. Cycads were a favorite food of the dinosaurs. You can also see Benititalians and ginkgos." The world of the dinosaurs included more modern plants such as pine and fir trees and swamp cypresses. You will see these as well. The Land Cruiser moved slowly among the foliage. Tim noticed the fences and retaining walls were screened by greenery and to heighten the illusion of moving through real jungle. "We imagine the world of the dinosaurs," said Richard Kiley's voice, "as a world of huge vegetarians eating their way through the giant swampy forests of the Jurassic and Cretaceous world 100 million years ago. But most dinosaurs were not as large as people think. The smallest dinosaurs were no bigger than a house cat, and the average dinosaur was as big as a pony. We are first going to visit one of these average-sized dinosaurs called Hypsilophodonts. If you look to your left, you may catch a glimpse of them now." They all looked to the left. The Land Cruiser stopped on a low rise where a break in the foliage provided a view to the east. They could see a sloping forested area which opened into a field of yellow grass that was about 3 feet high. There were no dinosaurs. "Where are they?" Lex said. Tim looked at the dashboard. The transmitter lights blinked and the CD-ROM whirred. Obviously, the disc was being accessed by some automatic system. He guessed that the same motion sensors that tracked the animals also controlled the screens in the Land Cruiser. The screens now showed pictures of Hypsilophodonts and printed out data about them. The voice said, "Hypsilophodonts are the gazelles of the dinosaur world. Small, quick animals that once roamed everywhere in the world, from England to Central Asia to North America. We think these dinosaurs were so successful because they had better jaws and teeth for chewing plants than their contemporaries did. In fact, the name Hypsilophodontid means high-ridged tooth, which refers to the characteristic self-sharpening teeth of these animals. You can see them in the plains directly ahead, and also perhaps in the branches of the trees." "In the trees?" Lex said. "Dinosaurs in the trees?" Tim was scanning with binoculars too. "To the right," he said, "halfway up that big green trunk." In the dappled shadows of the tree, a motionless, dark green animal about the size of a baboon stood on a branch. It looked like a lizard standing on its hind legs. It balanced itself with a long, drooping tail. "That's an Othnielia," Tim said. "The small animals you see here are called Othnielia," the voice said, in honor of the 19th century dinosaur hunter Othniel Marsh of Yale. Tim spotted 2 more animals on higher branches of the same tree. They were all about the same size. None of them were moving. "Pretty boring," Lex said. "They're not doing anything." "The main herd of animals can be found in the grassy plain below you," said the voice. "We can rouse them with a simple mating call." A loud speaker by the fence gave a long nasal call like the honking of geese. From the field of grass directly to their left, 6 lizard heads poked up, one after another. The effect was comical and Tim laughed. The heads disappeared. The loudspeaker gave the call again, and once again the heads poked up, in exactly the same way, one after another. The fixed repetition of the behavior was striking. Hypsilophodons are not especially bright animals, the voice explained. They have roughly the intelligence of a domestic cow. The heads were dull green with a mottling of dark browns and blacks that extended down the slender necks. Judging from the size of the heads, Tim guessed their bodies were 4 feet long, about as large as a deer. Some of the Hypsilophodons were chewing, the jaws working. One reached up and scratched its head with a 5-fingered hand. The gesture gave the creature a pensive, thoughtful quality. If you see them scratching, that is because they have skin problems. The veterinary scientists here at Jurassic Park think it may be a fungus or an allergy, but they're not sure yet. After all, these are the first dinosaurs in history ever to be studied alive. The electric motor of the car started and there was a grinding of gears. At the unexpected sound, the herd of Hypsilophodons suddenly leapt in the air and bounded above the grass like kangaroos, showing their full bodies with massive hind legs and long tails in the afternoon sunlight. In a few leaps, they were gone. Now that we've had a look at these fascinating herbivores, we will go on to some dinosaurs that are a little larger, quite a bit larger in fact. The land cruisers continued onward, moving south through Jurassic Park. Control. Gears are grinding, John Arnold said in the darkened control room. Have maintenance check the electric clutches on vehicles BB4 and BB5 when they come back. Yes, Mr. Arnold, replied the voice on the intercom. A minor detail, Hammond said, walking into the room. Looking out, he could see the 2 land cruisers moving south through the park. Muldoon stood in the corner, silently watching. Arnold pushed his chair back from the central console of the control panel. There are no minor details, Mr. Hammond, he said, and he lit another cigarette. Nervous at most times, Arnold was especially edgy now. He was only too aware that this was the first time visitors had actually toured the park. In fact, Arnold's team didn't often go into the park. Harding, the vet, sometimes did. The animal handlers went into the individual feeding houses, but otherwise they watched the park from the control room. And now with visitors out there, he worried about 100 details. John Arnold was a systems engineer who had worked on the Polaris submarine missile in the late 1960s, until he had his first child and the prospect of making weapons became too distasteful. Meanwhile, Disney had started to create amusement park rides of great technological sophistication, and they employed a lot of aerospace people. Arnold helped build Disney World in Orlando and had gone on to implement major parks at Magic Mountain in California, Old Country in Virginia, and Astroworld in Houston. His continuous employment at parks had eventually given him a somewhat skewed view of reality. Arnold contended, only half-jokingly, that the entire world was increasingly described by the metaphor of the theme park. Paris is a theme park, he once announced after a vacation, although it's too expensive and the park employees are unpleasant and sullen. For the past 2 years, Arnold's job had been to get Jurassic Park up and running. As an engineer, he was accustomed to long time schedules. He often referred to the September opening, by which he meant September the following year, and as the September opening approached, he was unhappy with the progress that had been made. He knew from experience that it sometimes took years to work out the bugs of a single park ride, let alone get a whole park running properly. "You're just a warrior," Hammond said. "I don't think so," Arnold said. "You gotta realize that from an engineering standpoint, Jurassic Park is the most ambitious theme park in history. Visitors will never think about it, but I do." He ticked the points off his fingers. First, Jurassic Park has all the problems of any amusement park. Ride maintenance, queue control, transportation, food handling, living accommodations, trash disposal, security. Second, we have all the problems of a major zoo. Care of the animals, health and welfare, feeding and cleanliness, protection from the insects, pests, allergies, illnesses, maintenance of barriers, and all the rest. And finally, we have the unprecedented problem of caring for a population of animals that no one has ever tried to maintain before. "Oh, it's not as bad as all that," Hammond said. "Yes, it is. You're just not here to see it," Arnold said. "The Tyrannosaurs drink the lagoon water and sometimes get sick. We aren't sure why. The Triceratops females kill each other in fights for dominance and have to be separated into groups smaller than 6. We don't know why. The Stegosaurs frequently get blisters on their tongues and diarrhea, for reasons no one yet understands, even though we've lost 2. Hypsilophodons get skin rashes, and the Velociraptors..." "Let's not start on the Velociraptors," Hammond said. "I'm sick of hearing about the Velociraptors, how they're the most vicious creatures anyone has ever seen.
They are, Muldoon said in a low voice. They should all be destroyed.
You wanted to fit them with radio collars, Hammond said, and I agreed.
Yes, and they promptly chewed the collars off. But even if the raptors never get free, Arnold said, I think we have to accept that Jurassic Park is inherently hazardous.
Oh, balls, Hammond said. Whose side are you on, anyways?
We now have 15 species of extinct animals, and most of them are dangerous, Arnold said. We've been forced to delay the Jungle River ride because of the Dilophosaurs, and the Triceratops Lodge in the aviary because the pterodactyls are so unpredictable. These aren't engineering delays, Mr. Hammond. They're problems with control of the animals.
You've had plenty of engineering delays, Hammond said. Don't blame it on the animals.
Yes, we have. In fact, it's all we could do to get the main attraction park drive working correctly, to get the CD-ROMs inside the cars to be controlled by the motion sensors. It's taken weeks of adjustment to get that working properly. And now, the electric gear shifts on the cars are acting up. The gear shifts.
Let's keep it in perspective, Hammond said. You get the engineering correct, and all the animals will fall into place. After all, they're trainable.
From the beginning, this has been one of the core beliefs of the planners. The animals, however exotic, would fundamentally behave like animals in zoos anywhere. They would learn the regularities of their care, and they would respond.
Meanwhile, how's the computer? Hammond said.
He glanced at Dennis Nedry, who was working at a terminal in the corner of the room.
This damn computer has always been a headache.
We're getting there, Nedry said.
If you had done it right in the first place,
Hammond began, but Arnold put a restraining hand on his arm. Arnold knew there was no point in antagonizing Nedry while he was working. Hey, it's a large system, Arnold said. There are bound to be glitches. In fact, the bug list now ran to more than 130 items, and included many odd aspects. For example, the animal feeding program reset itself every 12 hours, not every 24 hours, and would not record feedings on Sundays. As a result, the staff could not accurately measure how much the animals were eating. The security system, which controlled all the security card operated doors, cut out whenever main power was lost, and did not come back on with auxiliary power. The security program only ran with main power. The physical conservation program, intended to dim lights after 10 o'clock p.m., only worked on alternate days of the week. The automated fecal analysis, called autopoop, designed to check for parasites in the animal stools, invariably recorded all specimens as having the parasite Phagostomum venosum, although none did. The program then automatically dispensed medication into the animal's foods. If the handlers dumped the medicine out of the hoppers to prevent its being dispensed, an alarm sounded which could not be turned off. And so it went, page after page of errors. When he had arrived, Dennis Nedry had been under the impression that he could make all the fixes himself over the weekend. He had paled when he saw the full listing. Now he was calling his office in Cambridge, telling his staff programmers they were going to have to cancel their weekend plans and work overtime until Monday. And he had told John Arnold that he would need to use every telephone link between Isla Nublar and the mainland just to transfer program data back and forth to his programmers. While Nedry worked, Arnold punched up a new window in his own monitor. It allowed him to see what Nedry was doing at the corner console. Not that he didn't trust Nedry, but Arnold just liked to know what was going on. He looked at the graphics display on his right-hand console, which showed the progress of the electric land cruisers. They were following the river just north of the aviary, in the Ornithischian paddock. If you look to your left, said the voice, you will see the dome of the Jurassic Park aviary, which is not yet finished for visitors. Tim saw sunlight glinting off aluminum struts in the distance. And directly below is our Mesozoic jungle river, where, if you are lucky, you just may catch a glimpse of a very rare carnivore. Keep your eyes peeled, everyone. Inside the Land Cruiser, the screen showed a bird-like head topped with a flaming red crest, but everyone in Tim's car was looking out the windows. The car was driving along a high ridge, overlooking a fast-moving river below. The river was almost enclosed by dense foliage on both sides. There they are now, said the voice. The animals you see are called Dilophosaurus. Despite what the recording said, Tim saw only one. The Dilophosaur crouched on its hind legs by the river, drinking. It was built on the basic carnivore pattern, with a heavy tail, strong hind limbs, and a long neck. Its 10-foot-tall body was spotted yellow and black like a leopard. But it was the head that held Tim's attention. Two broad curving crests ran along the top of the head from the eyes to the nose. The crests met in the center, making a V shape above the dinosaur's head. The crest had red and black stripes, reminiscent of a parrot or a toucan. The animal gave a soft hooting cry like an owl.
They're pretty, Lex said.
Dilophosaurus, the tape said, is one of the earliest carnivores. Scientists thought their jaw muscles were too weak to kill prey, and imagined they were primarily scavengers. But now we know they are poisonous. Hey, Tim grinned. All right. Again, the distinctive hooting call of the Dilophosaur drifted across the afternoon air towards them. Lex shifted uneasily in her seat. Are they really poisonous, Mr. Regis? Oh, don't worry about it, Ed Regis said. But are they? Well, yes, Lex. Along with such living reptiles as Gila monsters and rattlesnakes, Dilophosaurus secretes a hemotoxin from glands in its mouth. Unconsciousness follows within minutes of a bite. The dinosaur will then finish the victim off at its leisure, making Dilophosaurus a beautiful but deadly addition to the animals you see here at Jurassic Park. The Land Cruiser turned a corner, leaving the river behind. Tim looked back, hoping for a last glimpse of the Dilophosaur. This was amazing. Poisonous dinosaurs. He wished he could stop the car, but everything was automatic. He bet Dr. Grant wanted to stop the car too. If you look on the bluff to your right, you'll see Les Gigantes, the site of our superb 3-star dining room. Chef Alain Richard hails from the world-famous Le Bolemer in France. Make your reservations by dialing 4 from your hotel rooms. Tim looked up the bluff and saw nothing. Not for a while, though, Ed Regis said. The restaurant won't even start construction until November. Continuing on our prehistoric safari, we come next to the herbivores of the Ornithischian group. If you look to your right, you can probably see them now. Tim saw 2 animals standing motionless in the shade of a large tree. Triceratops, the size and gray color of an elephant, and the truculent stance of a rhino. The horns above each eye curved 5 feet into the air, looking almost like an inverted elephant tusks. A third rhino-like horn was located near the nose, and they had the beaky snout of a rhino. Unlike any dinosaurs, the voice said, Triceratops serratus can't see well. They're nearsighted like the rhinos of today, and they tend to be surprised by moving objects. They'd charge our car if they were close enough to see it. But relax, folks, we're safe enough here. Triceratops has a fan-shaped crest behind their heads. It's made of solid bone, and it's very strong. These animals weigh about 7 tons each. Despite their appearance, they are actually quite docile. They know their handlers, and they'll allow themselves to be petted. They particularly like to be scratched in the hindquarters. Why don't they move? Lex said. She rolled down her window. Hey, stupid dinosaur, move! Don't bother the animals, Lex, Ed Regis said. Why? It's stupid. They just sit there like a picture in a book, Lex said. The voice was saying, easygoing monsters from a bygone world stand in sharp contrast to what we will see next. The most famous predator in the history of the world. The mighty tyrant lizard, known as Tyrannosaurus Rex. Good, Tyrannosaurus Rex, Tim said. I hope he's better than these bozos, Lex said, turning away from the Triceratops. The Land Cruiser rumbled forward. Big Rex. The mighty Tyrannosaurs arose late in dinosaur history. Dinosaurs ruled the Earth for 120 million years, but there were Tyrannosaurs for only the last 15 million years of that period. The Land Cruisers had stopped at the rise of a hill. They overlooked a forested area sloping down to the edge of the lagoon. The sun was falling to the west, sinking into a misty horizon. The whole landscape of Jurassic Park was bathed in soft light, with lengthening shadows. The surface of the lagoon rippled in pink crescents. Farther south, they saw the graceful necks of the Camarasaurs, standing at the water's edge, their bodies mirrored in the moving surface. It was quiet, except for the soft drone of cicadas. As they stared out at the landscape, it was possible to believe that they had really been transported millions of years back in time to a vanished world. It works, doesn't it? They heard Ed Regis say over the intercom. I like to come here sometimes in the evening and just sit. Grant was unimpressed. Where's T-Rex? Good question. You often see the little one down in the lagoon. The lagoon's stocked, so we have fish in there. The little one has learned to catch the fish. Interesting how he does it. He doesn't use his hands, but he ducks his whole head under the water like a bird. The little one? The little T-Rex. He's a juvenile, 2 years old and about a third grown now. Stands 8 feet high, weighs 1.5 tons. The other one's a full-grown Tyrannosaur, but I don't see him at the moment. Maybe he's hunting down the Camarasaurus, Grant said. Ed Regis laughed, his voice tinny over the radio. You would if you could, believe me. Sometimes he stands by the lagoon and stares at those animals and wiggles those little forearms of his in frustration. But the T-Rex territory is completely enclosed with trenches and fences. They're disguised from view, but believe me, he can't go anywhere.
And where is he?
Regis said. She's a little shy.
Shy? Malcolm said. Tyrannosaurus Rex is shy?
Well, he conceals himself as a general rule. You almost never see him out in the open, especially in daylight.
Why is that?
We think it's because he has sensitive skin and sunburns easily.
Malcolm began to laugh. Grant sighed. You're destroying a lot of illusions.
I don't think you'll be disappointed, Regis said. Just wait. They heard a soft bleeding sound. In the center of a field, a small cage rose up into view, lifted on hydraulics from underground. The cage bars slid down and the goat remained tethered in the center of the field, bleeding plaintively.
Any minute now, Regis said again. They stared out the window.
Look at them, Hammond said, watching the control room monitor. Leaning out of the window, so eager. They can't wait to see it. They have come for the danger.
That's what I'm afraid of, Muldoon said.
He twirled the keys on his finger and watched the land cruisers tensely. This was the first time that visitors had toured Jurassic Park, and Muldoon shared Arnold's apprehension. Robert Muldoon was a big man, 50 years old, with a steel-gray mustache and deep blue eyes. Raised in Kenya, he had spent most of his life as a guide for African big-game hunters, as had his father before him. But since 1980, he had worked principally for conservation groups and zoo designers as a wildlife consultant. He had become well known. An article in the London Sunday Times had said, "What Robert Trent Jones is to golf courses, Robert Muldoon is to zoos, a designer of unsurpassed knowledge and skill." In 1986, he had done some work for a San Francisco company that was building a private wildlife park on an island in North America. Muldoon had laid out the boundaries for different animals, defining space and habitat requirements for lions, elephants, zebras, and hippos, identifying which animals could be kept together and which had to be separated. At the time, it had been a fairly routine job. He had been more interested in the Indian park called Tiger World in southern Kashmir. Then, a year ago, he was offered a job as a game warden of Jurassic Park. It coincided with a desire to leave Africa. The salary was excellent. Muldoon had taken it on for a year. He was astonished to discover the park was really a collection of genetically engineered prehistoric animals. It was of course interesting work, but during his years in Africa, Muldoon had developed an unblinking view of animals, an unromantic view that frequently set him at odds with the Jurassic Park management in California, particularly the little martinet standing beside him in the control room. In Muldoon's opinion, cloning dinosaurs in the laboratory was one thing, maintaining them in the wild was quite another. It was Muldoon's view that some dinosaurs were too dangerous to be kept in a park setting. In part, the danger existed because they still knew so little about the animals. For example, nobody even suspected the Dilophosaurs were poisonous until they were observed hunting indigenous rats on the island, biting the rodents and then stepping back to wait for them to die. And even then, nobody suspected the Dilophosaurs could spit until one of the handlers was almost blinded by spitting venom. After that, Hammond had agreed to study Dilophosaur venom, which was found to contain 7 different toxic enzymes. It was also discovered that the Dilophosaurs could spit a distance of 50 feet. Since this raised the possibility that a guest in a car might be blinded, management decided to remove the poison sacs. The vets had tried twice on 2 different animals without success. No one knew where the poison was being secreted, and no one would ever know until an autopsy was performed on a Dilophosaur, and management would not allow one to be killed. Muldoon worried even more about the velociraptors. They were instinctive hunters, and they never passed up prey. They killed even when they weren't hungry. They killed for the pleasure of killing. They were swift, strong runners and astonishing jumpers. They had lethal claws on all 4 limbs. One swipe of a forearm would disembowel a man, spilling his guts out. And they had powerful tearing jaws that ripped flesh instead of biting it. They were far more intelligent than the other dinosaurs, and they seemed to be natural cage breakers. Every zoo expert knew that certain animals were especially likely to get free of their cages. Some, like monkey and elephants, can undo cage doors. Others, like wild pigs, were unusually intelligent and could lift gate fasteners with their snouts. But who would suspect that the giant armadillo was a notorious cage breaker, or a moose? Yet, a moose was almost as skillful with its snout as an elephant with its trunk. Moose were always getting free. They had a talent for it. And so did velociraptors.
Raptors were at least as intelligent as chimpanzees, and like chimpanzees, they had agile hands that enabled them to open doors and manipulate objects. They could escape with ease, and when, as Muldoon had feared, one of them finally escaped, it killed 2 construction workers and maimed a third before being recaptured. After that episode, the visitor lodge had been reworked with heavy barred gates, a high perimeter fence, and tempered glass windows. And the raptor holding pen was rebuilt with electronic sensors to warn of another impending escape. Muldoon wanted guns as well, and he wanted shoulder-mounted TOW missile launchers. Hunters knew how difficult it was to bring down a 4-ton African elephant, and some of the dinosaurs weighed 10 times as much. Management was horrified, insisting there be no guns anywhere on the island. When Muldoon threatened to quit and to take his story to the press, a compromise was reached. In the end, 2 specially built laser-guided missile launchers were kept in a locked room in the basement. Only Muldoon had the keys to the room. Those were the keys Muldoon was twirling now. "I'm going downstairs," he said. Arnold, watching the control screens, nodded. The 2 land cruisers still sat at the top of the hill, waiting for the T-Rex to appear. "Hey," Dennis Nedry called from the far console. "As long as you're up, give me a Coke, okay?" Grant waited in the car, watching quietly. The bleating of the goat became louder, more insistent. The goat tugged frantically at its tether, racing back and forth. Over the radio, Grant heard Lex saying in alarm,
"What's going to happen to the goat? Is she going to eat the goat?"
I think so.
someone said to her, and then Ellie turned the radio down. Then they smelled the odor, a garbage stench of putrefaction and decay that drifted up the hillside towards them. Grant whispered, "He's here." "She," Malcolm said. The goat was tethered in the center of the field, 30 yards from the nearest trees. The dinosaur must be somewhere among the trees, but for a moment Grant could see nothing at all. Then he realized he was looking too low. The animal's head stood 20 feet above the ground, half concealed among the upper branches of the palm trees. Malcolm whispered, "Oh my God, she's as large as a bloody building." Grant stared at the enormous square head, 5 feet long and mottled reddish-brown, with huge jaws and fangs. The Tyrannosaur's jaws worked once, opening and closing, but the huge animal did not emerge from hiding. Malcolm whispered, How long will it wait?" "Maybe 3 or 4 minutes." "Maybe." The Tyrannosaur sprang silently forward, fully revealing her enormous body. In 4 bounding steps, she covered the distance to the goat, bent down and bit it through its neck. The bleeding stopped. There was silence. Poised over her kill, the Tyrannosaur became suddenly hesitant. Her massive head turned on the muscular neck, looking in all directions. She stared fixedly at the land cruiser high above on the hill. Malcolm whispered, Can she see us?" "Oh yes," Regis said on the intercom. "Let's see if she's going to eat here in front of us or if she's going to drag the prey away." The Tyrannosaur bent down and sniffed the carcass of the goat. A bird chirped, her head snapped up, alert, watchful. She looked back and forth, scanning in small, jerking shifts. "Like a bird," Ellie said. Still the Tyrannosaur hesitated. What is she afraid of?" Malcolm whispered. "Probably another Tyrannosaur," Grant whispered. Big carnivores like lions and tigers often became cautious after a kill, behaving as if suddenly exposed. 19th century zoologists imagined the animals felt guilty for what they had done, but contemporary scientists documented the effort behind a kill, hours of patient stalking before the final lunge, as well as the frequency of failure. The idea of nature, red in tooth and claw, was wrong. Most often the prey got away. When a carnivore finally brought down an animal, it was watchful for another predator who might attack it and steal its prize. Thus, this Tyrannosaur was probably fearful of another Tyrannosaur. The huge animal bent over the goat again. One great hind limb held the carcass in place as the jaws began to tear the flesh. "She's gonna stay," Regis whispered. "Excellent." The Tyrannosaur lifted her head again, ragged chunks of bleeding flesh in her jaws. She stared at the land cruiser. She began to chew. They heard the sickening crunch of bones. "Ew," Lex said over the intercom. "That's disgusting." And then, as if caution had finally gotten the better of her, the Tyrannosaur lifted the remains of the goat in her jaws and carried it silently back among the trees. "Ladies and gentlemen, Tyrannosaurus Rex," the tape said. The land cruiser started up and moved silently off through the foliage. Malcolm sat back in his seat. Fantastic, he said. Gennaro wiped his forehead. He looked pale. Control. Henry Wu came into the control room to find everyone sitting in the dark, listening to the voices on the radio.
Jesus, if an animal like that gets out,
Gennaro was saying, his voice tinny on the speaker.
there'd be no stopping him.
Not stopping.
In the control room, Hammond said, "Damn those people! They are so negative!" Wu said, "They're still going on about an animal escaping? I don't understand. They must have seen by now that we have everything under control. We've engineered the animals and engineered the resort." He shrugged. It was Wu's deepest perception that the park was fundamentally sound, as he believed his paleo DNA was fundamentally sound. Whatever problems might arise in the DNA were essentially point problems in the code, causing a specific problem in the phenotype, an enzyme that didn't switch on or a protein that didn't fold. Whatever the difficulty, it was always solved within a relatively minor adjustment in the next version. Similarly, he knew that Jurassic Park's problems were not fundamental problems. They were not control problems. Nothing as basic or as serious as the possibility of an animal escaping. Wu found it offensive to think that anyone would believe him capable of contributing to a system where such a thing could happen. "It's that Malcolm," Hammond said darkly. "He's behind it all. He was against us from the start, you know. He's got his theory that complex systems can't be controlled and nature can't be imitated. I don't know what his problem is. Hell, we're just trying to make a zoo here. World's full of them and they all work fine, but he's gonna prove his theory or die trying. I just hope he doesn't panic Gennaro into trying to shut the park down." Wu said, "Can he do that?" "No," Hammond said, "but he can try. He can try and frighten the Japanese investors and get them to withdraw funds, or he can make a stink with the San Jose government. He can make trouble." Arnold stubbed out his cigarette. "Let's wait and see what happens," he said. "We believe in the park. Let's see how it plays out." Muldoon got off the elevator, nodded to the ground floor guard, and went downstairs to the basement. He flicked on the lights. The basement was filled with 24 Land Cruisers, arranged in neat rows. These were the electric cars that could eventually form an endless loop, touring the park, returning to the visitor center. In the corner was a Jeep with a red stripe, one of the 2 gasoline-powered vehicles. Harding, the vet, had taken the other that morning, which could go anywhere in the park, even among the animals. The Jeeps were painted with a diagonal red stripe because for some reason it discouraged the Triceratops from charging the car. Muldoon moved past the Jeep toward the back. The steel door to the armaments room was unmarked. He unlocked it with his key and swung the heavy door wide, gun racks lined the interior. He pulled out a Randler shoulder launcher and a case of canisters. He tucked 2 gray rockets under his other arm. After locking the door behind him, he put the gun into the back seat of the Jeep. As he left the garage, he heard the distant rumble of thunder. "Looks like rain," Ed Regis said, glancing up at the sky. The Land Cruisers had stopped again near the sauropod swamp. A large herd of apatosaurs was grazing at the edge of the lagoon, eating the leaves of the upper branches of the palm trees. In the same area were several duck-billed hadrosaurs, which in comparison looked much smaller. Of course, Tim knew the hadrosaurs weren't really small. It was only that the apatosaurs were so much larger. Their tiny heads reached 50 feet into the air, extending out onto their long necks. "The big animals you see are commonly called Brontosaurus," the recording said, "but they are actually Apatosaurus. They weigh more than 30 tons. That means a single animal is as big as a whole herd of modern elephants. And you may notice that their preferred area along the lagoon is not swampy. Despite what the book said, Brontosaurus avoid swamp. They prefer dry land." "Brontosaurus is the biggest dinosaur, Lex," Ed Regis said. Tim didn't bother to contradict him. Actually, Brachiosaurus was 3 times as large, and some people thought Ultrasaurus and Seismosaurus were even larger than Brachiosaurus. Seismosaurus might have weighed 100 tons. Alongside the apatosaurs, the smaller hadrosaurs stood on their hind legs to get at foliage. They moved gracefully for such large creatures. Several infant hadrosaurs scampered around the adults, eating the leaves that dropped from the mouths of the larger animals. "The dinosaurs of Jurassic Park don't breed," the recording said. "The young animals you see here were introduced a few months ago, already hatched, but the adults nurture them anyways." There was the rolling growl of thunder. The sky was darker, lower, and menacing. "Yep, looks like rain all right," Ed Regis said. The car started forward, and Tim looked back at the hadrosaurs. Suddenly, off to one side, he saw a pale yellow animal moving quickly. There were brownish stripes on his back. He recognized it instantly. "Hey!" he shouted. "Stop the car!" "What is it?" Ed Regis said. "Quick, stop the car!" We move on now to see the last of our great prehistoric animals, the Stegosaurs, the recorded voice said. "What's the matter, Tim?" "I saw one! I saw one in the field out there!" "Saw what?" "A raptor in that field!" The Stegosaurs are a mid-Jurassic animal, evolving about 170 million years ago, the recording said. Several of these remarkable herbivores live here at Jurassic Park. "Oh, I don't think so, Tim," Ed Regis said. "Not a raptor." "I did! Stop the car!" There was a babble on the intercom as the news was relayed to Grant and Malcolm. Tim said he saw a raptor." "Where?" Back at the field." "Well, let's go back and look."
We can't go back.
Ed Regis said.
We can only go forward. The cars are programmed.
"We can't go back?" Grant said.
No.
Regis said.
Sorry, you see, it's kind of a ride.
Tim, this is Professor Malcolm, said a voice cutting in on the intercom. "I have just one question for you about this raptor. How old would you say it is?"
Older than the baby we saw today, Tim said, and younger than the big adults in the pen. The adults were 6 feet tall. This one was about half that size.
"That's fine," Malcolm said.
"I only saw it for a second,"
Tim said.
I'm sure it wasn't a raptor,"
Ed Regis said. "It couldn't possibly be a raptor. Must have been one of the Aussies. They're always jumping the fences. We have a hell of a time with them." "I know I saw a raptor," Tim said. "I'm hungry," Lex said. She was starting to whine. In the control room, Arnold turned to Wu. "What do you think the kid saw?" "I think it must have been an Aussie." Arnold nodded. "We have trouble tracking Aussies because they spend so much time in the trees." The Aussies were an exception to the usual minute-to-minute control they maintained over the animals. The computers were constantly losing and picking up the Aussies as they went into the trees and then came down again. "What burns me," Hammond said, "is that we have made this wonderful park, this fantastic park, and our very first visitors are going through it like accountants just looking for problems. They aren't experiencing the wonder of it at all." "That's their problem," Arnold said. "We can't make them experience wonder." The intercom clicked and Arnold heard a voice drawl.
John, this is the NB over at the dock. We haven't finished offloading, but I'm looking at the storm patterns ahead of us. I'd rather not be tied up here if the job gets any worse."
Arnold turned to the monitor showing the cargo vessel, which was moored at the dock on the east side of the island. He pressed the radio button. "How much left to do, Jim?"
Just the 3 final equipment containers. I haven't checked the manifest, but I assume you can wait another 2 weeks for it. We're not well berthed here, you know. We are out 100 miles offshore.
"You requesting permission to leave?"
Yes, John.
"I want that equipment," Hammond said. "That's equipment for the labs. We need it." "Yes," Arnold said, "but you didn't want to put money into a storm barrier to protect the pier. So we don't have a good harbor. If the storm gets worse, the ship will be pounded against the dock. I've seen ships lost that way. Then you got all the other expenses, replacement of the vessel plus salvage to clear your dock, and you can't use your dock until you do." Hammond gave a dismissing wave. "Get them out of there." "Permission to leave, Anby," Arnold said into the radio.
See you in 2 weeks.
The voice said. On the video monitor, they saw the crew on the decks, casting off the lines. Arnold turned back to the main console bank. He saw the land cruisers moving through fields of steam. "Where are they now?" Hammond said. "It looks like the south fields," Arnold said. "The southern end of the island has more volcanic activity than the north. That means they should be almost to the Stegos. I'm sure they'll stop and see what Harding is doing." Stegosaur. As the land cruiser came to a stop, Ellie Sattler stared through the plumes of steam at the Stegosaurus. It was standing quietly, not moving. A jeep with a red stripe was parked alongside it. "Oh, I have to admit, that's a funny-looking animal," Malcolm said. The Stegosaurus was 20 feet long, with a huge bulky body and vertical armor plates along its back. The tail had dangerous-looking 3-foot spikes, but the neck tapered to an absurdly small head with a stupid gaze like a dumb horse. As they watched, a man walked around from behind the animal. "That's our vet, Dr. Hardin," Regis said over the radio. "He's anesthetized the stego, which is why it's not moving. It's sick." Grant was already getting out of the car, hurrying toward the motionless Stegosaur. Ellie got out and looked back as the second land cruiser pulled up and the 2 kids jumped out. "What's he sick with?" Tim said. "They're not sure," Ellie said. The great leathery plates along the Stegosaur's spine drooped slightly. It breathed slowly, laboriously, making a wet sound with each breath. Is it contagious? Lex said. They walked toward the tiny head of the animal where Grant and the vet were on their knees peering into the stegosaur's mouth. Lex wrinkled her nose. This thing sure is big, she said, and smelly. Yes, it is. Ellie had already noticed the stegosaur had a peculiar odor like rotting fish. It reminded her of something she knew but couldn't quite place. In any case, she had never smelled a stegosaur before. Maybe this was its characteristic odor, but she had her doubts. Most herbivores did not have a strong smell, nor did their droppings. It was reserved for the meat eaters to develop a real stink. Is that because it's sick? Lex asked. Oh, maybe. And don't forget the vets tranquilized it.
Ellie, take a look at this tongue, Grant said. The dark purple tongue drooped limply from the animal's mouth. The vet shone a light on it so she could see the very fine silvery blisters.
Microvesicles, Ellie said. Interesting.
You've had a difficult time with these stegos, the vet said. They're always getting sick.
What are the symptoms? Ellie asked. She scratched the tongue with her fingernail. A clear liquid exuded from the broken blisters. Ugh, Lex said.
Well, imbalance, disorientation, labored breathing, and massive diarrhea, Harding said. It seems to happen about once every 6 weeks or so.
They feed continuously?
Oh yes, Harding said. Animal this size has to take in a minimum of 500 or 600 pounds of plant matter daily just to keep going. They're constant foragers.
Then it's not likely to be poisoning from a plant, Ellie said.
Constant browsers would be constantly sick if they were eating a toxic plant. Not every 6 weeks. Exactly, the vet said.
May I? Ellie asked.
She took the flashlight from the vet.
You have pulpitary effects from the tranquilizer? She said, shining the light in the stegosaur's eye.
Yes, there's a miotic effect. Pupils are constricted.
But these pupils are dilated, she said.
Harding looked. There was no question. The stegosaur's pupil was dilated. It did not contract when light shone on it.
I'll be damned, he said.
That's a pharmacological effect.
Yes. Ellie got back on her feet and looked around. What is the animal's range?
About 5 square miles.
In this general area? She asked.
They were in an open meadow with scattered rocky outcrops and intermittent plumes of steam rising from the ground. It was late afternoon and the sky was pink beneath the lowering gray clouds.
Their range is northerly north or east of here, Harding said, but when they get sick, they're usually somewhere around this particular area. It was an interesting puzzle, she thought, how to explain the periodicity of the poisoning. She pointed across the field. You see those little delicate-looking bushes?
West Indian lilac, Harding nodded.
We know it's toxic, but the animals don't eat it.
You're sure?
Yes, we monitor them on video and have checked droppings just to be certain. The stegos never eat the lilac berries. Melia azadirach, called China berry or West Indian lilac, contained a number of toxic alkaloids. The Chinese use the plant as a fish poison.
They don't eat it, the vet said.
Interesting, Ellie said, because otherwise I would have said that this animal shows all the classic signs of melia toxicity. Stupor, blistening of the mucous membranes, and pulpitary dilation. She set off toward the field to examine the plants more closely, her body bent over the ground. You're right, she said. Plants are healthy, no sign of being eaten. None at all.
And then there's the 6-week interval, the vet reminded her.
The stegosaurs come here how often?
About once a week, he said. Stegos make a slow loop through the home range territory, feeding as they go.
They complete the loop in about a week? Once every 6 weeks.
Correct, Harding said.
This is boring, Lex said. Shh, Tim said. Dr. Sattler's trying to think.
Unsuccessfully, Ellie said, walking farther out onto the field. Behind her, she heard Lex saying,
Anyone want to play a little pickle?
Ellie stared at the ground. The field was rocky in many places. She could hear the sound of the surf somewhere to the left. There were berries among the rocks. Perhaps the animals were just eating berries. But that didn't make sense. West Indian lilac berries were terribly bitter. Finding anything? Grant said, coming up to join her.
Ellie sighed. Just rocks, she said. We must be near the beach because all these rocks are smooth, and they're in funny little piles.
Funny little piles? Grant said.
All over. There's one pile right there, she pointed.
As soon as she did, she realized what she was looking at. The rocks were warm, but it had nothing to do with the ocean. These rocks were heaped in small piles, almost as if they had been thrown down that way. They were piles of gizzard stones.
Many birds and crocodiles swallowed small stones, which collected in a muscular pouch in the digestive tract called the gizzard. Squeezed by the muscles of the gizzard, the stones helped crush tough plant food before it reached the stomach, and thus aided digestion. Some scientists thought dinosaurs also had gizzard stones. For one thing, dinosaur teeth were too small and too little worn to have been used for chewing food. It was presumed that dinosaurs swallowed their food whole and let the gizzard stones break down the plant fibers, and some skeletons have been found with an associated pile of small stones in the abdominal area. But it had never been verified. And gizzard stones, Grant said. I think so, yes. They swallow these stones, and after a few weeks the stones are worn smooth, so they regurgitate them, leaving this little pile, and swallow fresh stones. And when they do, they swallow berries as well and get sick. I'll be damned, Grant said. I'm sure you're right. He looked at the pile of stones, brushing through them with his hand, following the instinct of a paleontologist. Then he stopped. Ellie, he said, take a look at this. Put it there, babe, right in the old mitt, Lex cried, and Gennaro threw the ball to her. She threw it back so hard that his hand stung. Ow, hey, take it easy, I don't have a glove. You wimp, she said contemptuously. Annoyed, he fired the ball at her and heard it smack in the leather. Now that's more like it, she said. Standing by the dinosaur, Gennaro continued to play catch as he talked to Malcolm. So how does this sick dinosaur fit into your theory? It's predicted, Malcolm said. Gennaro shook his head. Is anything not predicted by your theory? Look, Malcolm said, it has nothing to do with me. It's chaos theory, but I notice nobody is willing to listen to the consequences of the mathematics because they simply imply very large consequences for the human life, much larger than, Heisenberg's principle or Gödel's theorem, which everybody rattles on about. They are actually rather academic considerations, philosophical considerations, but chaos theory concerns everyday life. Do you know why computers were first built? No, Gennaro said. Burn it in there, Lex yelled. See, computers were built in the late 1940s because mathematicians like John von Neumann thought if you had a computer, a machine to handle a lot of variables simultaneously, you would be able to predict the weather. You see, weather would finally be able to fall to human understanding, and men believed that dream for the next 40 years. They believed that prediction was just a function of keeping track of things. If you knew enough, you could predict anything. That's been a cherished scientific belief since Newton. And, well, chaos theory throws it right out the window. It says you can never predict certain phenomena at all. You can never predict the weather more than a few days away. All the money that has been spent on long-range forecasting, about $500 million in the last few decades, is money wasted. It's a fool's errand. It's as pointless as trying to turn lead into gold. We look back at the alchemists and laugh at what they were trying to do, but future generations will laugh at us the same way. We try the impossible, and spend a lot of money doing it, because in fact there are great categories of phenomena that are inherently unpredictable. Chaos says that? Yes, and it is astonishing how few people care to hear it, Malcolm said. I gave all this information to him long before he broke ground on this place. You're going to engineer a bunch of prehistoric animals and set them on an island. Fine, a lovely dream, charming. But it won't go as planned. It is inherently unpredictable, just as the weather is. You told him this? Gennaro said. Yes, I also told him where the deviations would occur. Obviously, the fitness of the animals to the environment was one area. This Stegosaur is 100 million years old. It isn't adapted to our world. The air is different. The solar radiation is different. The land is different. The insects are different. The sounds are different. The vegetation is different. Everything is different. The oxygen content is decreased. This poor animal's like a human being at 10,000 feet altitude. Listen to him wheezing. And the other areas? Well, broadly speaking, the ability of the park to control the spread of life forms, because the history of evolution is that life escapes all barriers. Life breaks free, life expands to new territories, painfully, perhaps even dangerously, but life, finds a way. Malcolm shook his head. I don't mean to be philosophical, but, well, there it is. Gennaro looked over. Ellie and Grant were across the field, waving their arms and shouting. Did you get my Coke? Dennis Nedry asked as Muldoon came back into the control room. Muldoon didn't bother to answer. He went directly to the monitor and looked at what was happening. Over the radio, he heard Harding's voice saying,
This is Stego. Finally. Handle them now.
What's that about? Muldoon said. They're down by the south point, Arnold said. That's why they're breaking up a little. I'll switch them to another channel, but they found out what's wrong with the Stegos. Eating some kind of berry. Hammond nodded. I knew we'd solve that sooner or later, he said. It's not very impressive, Gennaro said. He held a white fragment no larger than a postage stamp up on his fingertips in the fading light. You sure about this, Alan? Absolutely sure, Grant said. What gives it away is the pattern on the interior surface, the interior curve. Turn it over and you will notice a faint pattern of raised lines making roughly triangular shapes. Yes, I see them. Well, I've dug out 2 eggs with patterns like that in my set in Montana. You're saying this is a piece of dinosaur eggshell? Absolutely, Grant said. Harding shook his head. But these dinosaurs can't breed? Evidently they can, Gennaro said. That must be a bird egg, Harding said. We literally had dozens of species on the island. Grant shook his head. Well, look at the curvature. Its shell is almost flat. That's from a very big egg. And notice the thickness of the shell. Unless you have ostriches on this island, it's a dinosaur egg. But they can't possibly breed, Harding insisted. All the animals are female. All I know, Grant said, is that this is a dinosaur egg. Malcolm said, Can you tell the species? Yes, Grant said. It's a velociraptor egg. Control. Absolutely absurd, Hammond said in the control room, listening to the reporter of the radio. It must be a bird egg. That's all it can be. The radio crackled. He heard Malcolm's voice.
Let's do a little test, shall we? Ask Mr. Arnold to run one of his computer tallies.
Now?
Yes, right now. I understand you can transmit it to the screen in Dr. Harding's car. Do that too, will you?
No problem, Arnold said. A moment later, the screen in the control room printed out. I hope you're satisfied, Hammond said. Are you receiving it down there on your screen?
We see it,
Malcolm said. Everything's accounted for as always. He couldn't keep the satisfaction out of his voice.
No, Malcolm said. Can you search for can you have the computer search for a different number of animals?
Like what? Arnold said.
Try 239.
Just a minute, Arnold said, frowning. A moment later, the screen printed. Hammond sat forward. What the hell is that? We picked up another copy. From where? I don't know. The radio crackled.
Now then, can you ask the computer to search for, let's say, 300 animals?
What is he talking about? Hammond said, his voice rising. 300 animals? What's he talking about? Just a minute, Arnold said. That'll take a few minutes. He punched buttons on the screen. The first line of the totals appeared. I don't understand what he's driving at, Hammond said. I'm afraid I do, Arnold said. He watched the screen. The numbers on the first line were clicking. 234, Hammond said. What is going on? The computer is counting the animals in the park, Wu said. All the animals. I thought that's what it did. He spun. Nedry, have you screwed up again? No, Nedry said, looking up from his console. Computer allows the operator to enter an expected number of animals in order to make the counting process faster, but it's a convenience, not a flaw. He's right, Arnold said. We just always used the base count of 238 because we assumed there couldn't be more. Wait a minute, Hammond said. These animals can't breed. The computer must be counting field mice or something. I think so too, Arnold said. It's almost certainly an error in the visual tracking, but we'll know soon enough. Hammond turned to Wu. They can't breed, can they? No, Wu said. Where are they coming from? Arnold said. Damned if I know, Wu said. They watched the numbers climb. Over the radio, they heard Gennaro say,
Holy shit, how much more?
Then they heard the girl say,
I'm getting hungry. When are we going home?
Brady, sit and relax.
On the screen, there was a flashing error message. Ha! An error, Hammond said, nodding. I thought so. I had the feeling all along there must be an error. But a moment later, the screen printed out 292. The radio crackled.
Now you see the flying procedures.
Malcolm said.
You only tracked the expected number of dinosaurs. You were worried about losing animals, but your procedures were designed to advise you instantly if you had less than the expected number. That wasn't the problem. The problem was you had more than the expected number.
Oh, Christ, Arnold said. There can't be more, Wu said. We know how many we've released. There can't be more than that.
I'm afraid so, Henry.
Malcolm said.
They're breeding.
No.
Even if you don't accept Grant's eggshell, you can prove it with your own data. Take a look at the Compy height map. Mr. Arnold will put it up for you. Notice anything about it?
Malcolm said. It's a poison distribution, Wu said. Normal curve.
But didn't you say you introduced the Compies in 3 batches? At 6-month intervals?
Yes.
Well then, you should get a graph with peaks for each of the 3 separate batches that were introduced.
Malcolm said, typing the keyboard.
Like this. But you didn't get this graph, Malcolm said. The graph you actually got is a graph of a breeding population. Your Compies are breeding.
Wu shook his head. I don't see how.
They're breeding. And so are the Ophelia, the Dinosaurs, the Hypsies, and the Velociraptors.
Oh, Christ, Muldoon said. There are raptors free in the park. Well, it's not that bad, Hammond said, looking at the screen. We have increases in just 3 categories. Well, 5 categories. Very small increases in 2 of them. What are you talking about? Wu said loudly. Do you not know what this means? Of course I know what this means, Henry, Hammond said. It means you screwed up. Absolutely not. You got breeding dinosaurs out there, Henry. But they're all female, Wu said. It's impossible. There must be a mistake. And look at these numbers. A small increase in the big animals, the myosaurs, the hypsies, and big increases in the number of small animals. It just doesn't make sense. It must be a mistake. The radio clicked.
Actually not,
Grant said.
I think these numbers confirm that breeding has taken place in 7 different sites around the island.
Breeding sites. The sky was growing darker. Thunder rumbled in the distance. Grant and the others leaned in the doors of the Jeep, staring at the screen on the dashboard.
Breeding sites?
Wu said over the radio. Nests, Grant said. Assuming the average clutch is 8 to 12 hatching eggs, this data would indicate the Compies have 2 nests. The Raptors have 2 nests. The Authis have 1 nest. And the Hypsies and the Mayas have 1 nest each.
Where are these nests?
We'll have to find them, Grant said. Dinosaurs build their nests in secluded places.
But why are there so few big animals?
Wu said.
If there was a Maya nest of 8 to 12 eggs, there should be 8 to 12 new Mayas, not just 1.
That's right, Grant said. Except that the raptors and the Compies are loose in the park are probably eating the eggs of the bigger animals. And probably eating the newly hatched young as well.
But we've never seen that.
Arnold said over the radio. Raptors are nocturnal, he said. Is anyone watching the park at night? There was a long silence. I didn't think so, Grant said.
It still doesn't make any sense.
Wu said.
You can't support 50 additional animals on a couple nests of eggs.
No, Grant said. I assume they are eating something else as well. Perhaps, small rodents. Mice and rats. There was another silence. Let me guess, Grant said. When you first came to the island, you had a problem with rats, but as time passed, the problem faded away.
Yes, that's true.
And you never thought to investigate why.
Well, we just assumed.
Arnold said.
Look, Wu said, the fact remains all the animals are female. They can't breed.
Grant had been thinking about that. He had recently learned of an intriguing West German study that he suspected held the answer. When you made your dinosaur DNA, Grant said, you were working with fragmentary pieces, is that right?
Yes.
Wu said. In order to make the complete strand, were you ever required to include DNA fragments from other species?
Occasionally, yes.
Wu said.
It's the only way to complete the job. Sometimes we included avian DNA from a variety of birds and sometimes reptilian DNA.
Any amphibian DNA? Specifically frog DNA?
Possibly. I'd have to check.
Check, Grant said. I think you'll find that holds your answer. Malcolm said, frog DNA? Why frog DNA? Gennaro said impatiently, listen, this is all very intriguing, but we're forgetting the main question. Have any animals gotten off the island? Grant said, we can't tell from the data. Then how are we going to find out? There's only one way I know, Grant said. We'll have to find the individual nests, inspect them, count the remaining egg fragments. From that, we may be able to determine how many animals were originally hatched, and we can begin to assess whether any are missing. Malcolm said, even so, you wouldn't know if the missing animals are killed or dead from natural causes or whether they have left the island. No, Grant said, but it's a start, and I think we could get more information from an intensive look at the population graphs. How are we going to find these nests? Actually, Grant said, I think the computer will be able to help us out with that. Can we go back now? Lex said, I'm hungry. Yes, let's go, Grant said, smiling at her. You've been very patient. You'll be able to eat in about 20 minutes, Ed Regis said, starting toward the two land cruisers. If you don't mind, I'm going to stay for a while, Ellie said, and get photos of the Stego with Dr. Hardin's camera. Those vesicles in the mouth will have cleared up by tomorrow. I want to get back, Grant said. I'll go with the kids. I think I will too, Malcolm said. I think I'll stay, Gennaro said, and go back with Harding in his jeep with Dr. Sattler. Fine, let's go. They started walking. Malcolm said, so, why exactly is our lawyer staying? Grant shrugged. Think it might have something to do with Dr. Sattler. Really? The shorts, you think? It's happened before, Grant said. When they came to the land cruisers, Tim said, I want to ride in the front one this time with Dr. Grant. Malcolm said, unfortunately, Dr. Grant and I have to talk. We need to talk. I'll just sit and listen. I won't say anything, Tim said. Well, it's a private conversation, Malcolm said. Tell you what, Tim, Ed Regis said. Let them sit in the rear car by themselves. We'll sit in the front car and you can use the night vision goggles. Have you ever used night vision goggles, Tim? They're goggles with very sensitive CCDs that allow you to see in the dark. Neat, he said, and moved toward the first car. Hey, Lex said, I want to use it too. No, Tim said. No fair, no fair. You get to do everything, Timmy. Ed Regis watched them go and said to Grant, I can see what the ride back is going to be like. Grant and Malcolm climbed into the second car. A few raindrops splattered onto the windshield. Let's get going, Ed Regis said. I'm about ready for dinner, and I can do with a nice banana daiquiri. What do you say, folks? Daiquiri sound good? He pounded the metal panel of the car. See you back at camp, he said, and he started running toward the first car and climbed aboard. A red light on the dashboard blinked. With a soft electric whir, the Land Cruiser started off. Driving back in the faded light, Malcolm seemed oddly subdued. Grant said, You must feel vindicated about your theory. Well, as a matter of fact, I'm feeling a bit of dread. I suspect we are at a very dangerous point. Why? Intuition. Do mathematicians believe in intuition? Absolutely. Very important intuition. Actually, I was thinking of fractals, Malcolm said. Do you know about fractals? Grant shook his head. Not really, no. You see, fractals are a kind of geometry associated with a man named Mandelbrot. You see, unlike ordinary Euclidean geometry that everybody learns in schools, squares and cubes and spheres, fractal geometry appears to describe real objects in the natural world. Mountains and clouds are fractal shaped, so fractals are probably related to reality somehow. Well, Mandelbrot found a remarkable thing with his geometric tools. He found that things looked almost identical at different scales. At different scales? Grant said. For example, Malcolm said, a big mountain, seen from far away, has a certain rugged mountain shape. If you get closer and examine a small peak of the big mountain, it will have the same mountain shape. In fact, you can go all the way down to the scale of a tiny speck of rock, seen under a microscope. It will have the same fractal shape as the big mountain. I don't really see why this is worrying you, Grant said. He yawned. He smelled the sulfur fumes of the volcanic steam. They were coming now to the section of road that ran near the coastline, overlooking the beach and the ocean. Yeah, it's a way of looking at things, Malcolm said. Mandelbrot, you see, found a sameness from the smallest to the largest. And this sameness of scale also occurs for events. Events? Okay, consider cotton prices, Malcolm said. There are good records of cotton prices going back more than 100 years. When you study fluctuations in cotton prices, you find that the graph of price fluctuations in the course of a day basically looks like the graph for a week, which looks like basically like the graph for a year or for 10 years. And that's how things are. A day is like a whole life. You start out doing one thing, but end up doing something else. Plan to run an errand, but never get there. And at the end of your life, your whole existence has that same haphazard quality too. Your whole life has the same shape as a single day. Well, guess it's one way to look at things, Grant said. No, Malcolm said, it's the only way to look at things, at least the only way that is true to reality. You see, the fractal idea of sameness carries within it an aspect of recursion, a kind of doubling back on itself, which means that events are unpredictable, that they can change suddenly and without warning. Okay? But, we have soothed ourselves into imagining sudden change as something that happens outside the normal order of things, an accident like a car crash, or beyond our control like a fatal illness. We do not conceive of sudden, radical, irrational change as built into the very fabric of existence, yet it is. And chaos theory teaches us, Malcolm said, that straight linearity, which we have come to take for granted in everything from physics to fiction, simply does not exist. Linearity is an artificial way of viewing the world. Real life isn't a series of interconnected events occurring one after another like beads strung on a necklace. Life is actually a series of encounters in which one event may change those that follow in a wholly unpredictable, even devastating way. Malcolm sat back in his seat, looking toward the other Land Cruiser a few yards ahead. That's a deep truth about the structure of our universe, but for some reason, we insist on behaving as if it were not true. At that moment, the cars jolted to a stop. "What's happened?" Grant said. Up ahead, they saw the kids in the car pointing toward the ocean. Offshore, beneath lowering clouds, Grant saw the dark outline of the supply boat making its way back toward Punta Arenas. "Why have we stopped?" Malcolm said. Grant turned on the radio and heard the girls saying excitedly, "Look there, Timmy! You see it? It's there!" Malcolm squinted at the boat. They talking about the boat? Apparently. Ed Regis climbed out of the front seat and came running back to the window. "I'm sorry," he said, "but the kids are all worked up. Do you have any binoculars here?" "For what?" "The little girl says she sees something on the boat, some kind of animal," Regis said. Grant grabbed the binoculars and rested his elbows on the window ledge of the Land Cruiser. He scanned the long shape of the supply ship. It was so dark it was almost a silhouette. As he watched, the ship's running lights came on, brilliant in the dark purple twilight. "Do you see anything?" Regis said. "No," Grant said. "They're low down," Lex said over the radio. "Look low down." Grant tilted his binoculars down, scanning the hull just above the waterline. The supply ship was broad-beamed, with a splashed flange that ran the length of the ship, but it was quite dark now, and he could hardly make out details. "No, nothing," I can see them, Lex said impatiently. Near the back, look near the back. How can she see anything in this light? Malcolm said. Kids can see, Grant said. They got a visual acuity we forgot we ever had. He swung the binoculars toward the stern, moving them slowly, and suddenly he saw the animals. They were playing, darting among the silhouetted stern structures. He could see them only briefly, but even in the fading light, he could tell that they were upright animals, about 2 feet tall, standing with stiff, balancing tails. You see them now? Lex said. I see them, he said. What are they? Oh, God. They're raptors, Grant said. At least 2, maybe more, juveniles. Jesus, Ed Regis said. That boat's going to the mainland. Malcolm shrugged. Now, don't get excited. Just call the control room and tell them to recall the boat. Ed Regis reached in and grabbed the radio from the dashboard. They heard hissing static and clicks as he rapidly changed channels. There's something wrong with this one, he said. It's not working. He ran off to the first land cruiser. They saw him duck into it. Then he looked back at him. There's something wrong with both the radios, he said. I can't raise the control room. Now let's get going, Grant said. In the control room, Muldoon stood before the big windows that overlooked the park. At 7 o'clock, the quartz floodlights came on all over the island, turning the landscape into a glowing jewel stretching away to the south. This was his favorite moment of the day. He heard the crackle of static from the radios. Land cruisers started again, Arnold said. They're on their way home. But why did they stop? Hammond said. And why can't we talk to them? I don't know, Arnold said. Maybe they turn off the radios in the cars. Probably the storm, Muldoon said. Interference from the storm. They'll be here in 20 minutes, Hammond said. You better call down and make sure the dining room is ready for them. Those kids are going to be hungry. Arnold picked up the phone and heard a steady, monotonous hiss. What's this? What's going on? Jesus, hang that up, Nedry said. You'll screw up the data stream. You've taken off all the phone lines, even the internal ones. I've taken all the lines that communicate outside, Nedry said, but your internal line should still work. Arnold punched console buttons one after another. He heard nothing but hissing on all the lines. Looks like you got 'em all. Sorry about that, Nedry said. I'll clear a couple for you at the end of the next transmission in about, 15 minutes. He yawned. Looks like a long weekend for me. I guess I'll go get that Coke now. He picked up his shoulder bag and headed for the door. Don't touch my console, okay? The door closed. What a slop, Hammond said. Yeah, Arnold said, but I guess he knows what he's doing. Alongside the side of the road, clouds of volcanic steam misted rainbows in the bright quartz lights. Grant said into the radio. How long does it take for the ship to reach the mainland?
18 hours,
Ed Regis said.
more or less. It's pretty reliable.
He glanced at his watch.
It should arrive around 11 tomorrow morning.
Grant frowned. You still can't talk to the control room?
Not so far.
How about Harding? Can't you reach him?
No, I tried. He may have his radio turned on.
Malcolm was shaking his head. Okay, so we're the only ones who know about the animals on the ship.
I'm trying to raise somebody.
Ed Regis said.
For Christ, we don't want those animals on the mainland.
How long until we get back to the base? From here, another 16-17 minutes, Ed Regis said. At night, the whole road was illuminated by big floodlights. It felt to Grant as if they were driving through a bright green tunnel of leaves. Large raindrops splattered the windshield. Grant felt the land cruiser slow, then stop. Now what? Lex said, I don't want to stop. Why did we stop? And then suddenly, all the floodlights went out. The road was plunged into darkness. Lex said, Hey! Probably just a power outage or something, Ed Regis said. I'm sure the lights will be on in a minute. Oh, what the hell? Arnold said, staring at his monitors. What happened? Muldoon said. You lose power. Yeah, but the only power on the perimeter. Only power on the perimeter. Everything in this building's working fine, but outside in the park, the power's gone. Lights, TV, cameras, everything. His remote video monitors had gone black. What about the 2 land cruisers? Stopped somewhere around the Tyrannosaur paddock. Well, Muldoon said, call maintenance and let's get that power back on. Arnold picked up one of his phones and heard hissing. Nedry's computers talking to each other. No phones. That damn Nedry. Where the hell is he? Dennis Nedry pushed open the door marked fertilization. With the perimeter power out, all the security card locks were disarmed. Every door in the building opened with a touch. The problems with the security system were high on Jurassic Park's bug list. Nedry wondered if anybody ever imagined that it wasn't a bug, that Nedry had programmed it that way. He had built in a classic trapdoor. Few programmers of large computer systems could resist the temptation to leave themselves a secret entrance. Partly it was common sense. If inept users locked up the system and then called you for help, you always had a way to get in and repair the mess. And partly it was kind of a signature. Kilroy was here. And partly it was insurance for the future. Nedry was annoyed with the Jurassic Park project late in the schedule. Engine had demanded extensive modifications to the system, but hadn't been willing to pay for them, arguing they should be included under the original contract. Lawsuits were threatened, letters were written to Nedry's other clients implying that Nedry was unreliable. It was blackmail, and in the end Nedry had been forced to eat his overages at Jurassic Park to make the changes that Hammond wanted. But later, when he was approached by Lewis Dodson at Biosyn, Nedry was ready to listen, and able to say that he could indeed get past Jurassic Park security. He could get into any room, any system, anywhere in the park, because he had programmed it that way, just in case. He entered the fertilization room. The lab was deserted as he had anticipated. All the staff was at dinner. Nedry unzipped his shoulder bag and removed the can of Gillette shaving cream. He unscrewed the base and saw the interior was divided into a series of cylindrical slots. He pulled on a pair of heavy insulated gloves and opened the walk-in freezer marked "Contents Viable, Biological Maintain, 10 degrees Celsius minimum." The freezer was the size of a small closet with shelves from floor to ceiling. Most of the shelves contained reagents and liquids in plastic sacks. To one side, he saw a smaller nitrogen cold box with a heavy ceramic door. He opened it, and a rack of small tubes slid out in a cloud of white liquid nitrogen smoke. The embryos were arranged by species: Stegosaurus, Apatosaurus, Hadrosaurus, Tyrannosaurus. Each embryo in a thin glass container wrapped in silver foil, stoppered with polyene. Nedry quickly took 2 of each, slipping them into the shaving cream can. Then he screwed the base of the can shut and twisted the top. There was a hiss of releasing gas inside, and the can frosted in his hands. Dodson had said there was enough coolant to last 36 hours, more than enough time to get back to San Jose. Nedry left the freezer, returning to the main lab. He dropped the can back in his bag and zipped it shut. He went back into the hallway. The theft had taken less than 2 minutes. He could imagine the consternation upstairs in the control room as they began to realize what had happened. All their security codes were scrambled and all the phone lines were jammed. Without his help, it would take hours to untangle the mess, but in just a few minutes, Nedry would be back in the control room setting things right, and no one would ever suspect what he had done. Grinning, Dennis Nedry walked down to the ground floor, nodded to the guard, and continued downstairs to the basement. Passing the neat lines of electric Land Cruisers, he went to the gasoline-powered Jeep parked against the wall. He climbed into it, noticing some odd gray tubing on the passenger seat. It looked almost like a rocket launcher, he thought, as he turned the ignition key and started the Jeep. Nedry glanced at his watch. From here, into the park, and 3 minutes straight to the East Dock. 3 minutes from there, back to the control room. Piece of cake. "Damn it," Arnold said, punching buttons on the control. "It's all screwed up." Muldoon was standing at the windows looking out at the park. The lights had gone out all over the island except in the immediate area around the main buildings. He saw a few staff personnel hurrying to get out of the rain, but no one seemed to realize anything was wrong. Muldoon looked over at the visitor lodge where the lights burned brightly. "Uh-oh," Arnold said. "We have real trouble." "What's that?" Muldoon said. He turned away from the window, and so he didn't see the Jeep drive out of the underground garage and head east along the maintenance road into the park. "That idiot Nedry turned off the security systems," Arnold said. "The whole building's opened up. None of the doors are locked anymore." "I'll notify the gods," Muldoon said. "That's the least of it," Arnold said. "When you turn off the security, you turn off all the peripheral fences as well." "The fences," Muldoon said. "The electrical fences," Arnold said. "They're off. All over the island." "You mean?" "That's right," Arnold said. "The animals can get out now." Arnold lit a cigarette. "Probably nothing will happen, but you never know." Muldoon started toward the door. "I better drive out and bring the people in those 2 Land Cruisers," he said, "just in case." Muldoon quickly went downstairs to the garage. He wasn't really worried about the fences going down. Most of the dinosaurs had been in their paddocks for 9 months or more, and they had brushed up against the fences more than once with notable results. Muldoon knew how quickly animals learn to avoid shock stimuli. You could train a laboratory pigeon with just 2 or 3 stimulation events, so it was unlikely the dinosaurs would now approach the fences. Muldoon was more concerned about what the people in the cars would do. He didn't want them getting out of the Land Cruisers because once the power came back on, the cars would start moving again whether the people were inside them or not. He might be left behind. Of course, in the rain, it was unlikely they would leave the cars, but still, you never knew. He reached the garage and hurried toward the Jeep. It was lucky he thought that he had the foresight to put the launcher in it. He could start right out and be out in... It was gone. What the hell? Muldoon stared at the empty parking space, astonished. The Jeep was gone. What the hell was happening? Inevitably, underlying instabilities begin to appear. Dr. Ian Malcolm.